that. We want to do the out. It's going to go to Top Cat again. It's an idiot. You are the first victim. Beat out Matt by about 3 seconds. How are you doing, Matt? Get some stuff lighted up. I'm rude. I'm rude. That's pretty convenient. Not much new. I've been seeing people playing with these 3-foot Home Depot Christmas lights, and I want to make my own. I can't afford to buy them, and good luck finding them. And I also got this idea that I want to make a measuring wheel. You know the let's see, I can show you what it looks like. Big, basically it's a C9 Christmas bulb, but it's gigantic, 3 feet tall. I'll show you when I have it lit up. Once we have more critters in here. And so I figured I want to make my own. Because I got lots of plastic and I don't have lots of money, so I'll just do my own. Trying to find a really cheap light socket. I guess this is probably going to be about the cheapest, isn't it? Socket like that is probably going to be the best bet. And you can get 6 of them for $10. Hard to argue with that. Hey, Mike, what are you up to today? That's 8, but it's not as nice, although being threaded is nice. Being threaded is really nice. I wish I could find the pigtail ones threaded. Let's see if I look long enough. Let's do E27 socket. Pigtail. There we go. Now I just need to find a threaded one. Because threaded would be really nice. Nope. Although, you know something, it is just a screw terminal. I think it really might be best to go with that. Then all I have to do is design the put a hole in your install plate to hold whatever light you want. I mean, it's Bakelite, but that's okay. It's black. It's going to be inside. Yeah, I think that's going to be the best bet. I'll keep looking though. It's also a good price. Although I was also thinking about making this thing run on 12 volts. Because then I could solar power the bad boy. So that's an idea too. But then again, all we have to do is design a light, and then you can design a mounting plate for whatever type of power or illumination you want. So, yes, keep it simple. Seeing if there's a better price on the sockets. Hey, 3D Medic, how are you doing? I like the idea of the screw base. It's also so far the cheapest. So for now, we'll stick with that. Good. This one is good. You full screen. You guys, once we switch this one, yes. There we go. Turn this a little bit. So I got two things that I've been working on, or wanting to work on. One, I want to make one of these because I want to run some light poles. I have light poles, 10-foot tall light poles, and I already have the lights, so I don't have to buy anything. But what I need is to know how long I need, what length do I need. And you guys, you've probably seen something like this before. You roll it along the ground and you measure how long something is, how, distance. Well, it just so happens that a 300 millimeter diameter circle is almost exactly 3 feet in circumference. Who'd have thought? I didn't realize that. But yeah, a 300 millimeter circle has a circumference of almost exactly 3 feet. Which means if I make a 300 millimeter wheel and put magnets 120 degrees spaced, I can use this to count off every time the magnet passes the induction sensor. And each time the magnet passes the induction sensor, this will tick up once. And that will be 1 foot. And so each full revolution of the wheel will be 3 feet. Only if it's exactly 300 millimeters. Because remember, we don't have to be super precise, but we do have to have some precision. I'm pretty sure a spool is a lot smaller than 300 millimeters. 3D. I want the spool diameter, you idiot. 200 millimeters. So your typical spool is 200 millimeters, which is too small. Okay. Radius 100. Which means that circumference would be 628 millimeters. So 628 divided by 25.4 is 24.72. Okay, it would be 2 foot. So I would use 2 magnets. That is possible. You could do that. I have a feeling, though, designing all the parts to attach to a 3D printing spool would take about the same, if not more, plastic than just printing the wheel. Because I can print the wheel pretty thin, while the adapter would have to be strong enough to attach to a spool. So yes, that could work. And even though your resolution is off by 0.72 inches per revolution, that's okay. I mean, we're talking about a rough measurement here. Hey, Maker Viking. So yes, you could do this with a spool. And it would be close enough. But the other difference, though, is that I can design the wheel to either be all PLA or PLA with a TPU ring for a little bit better traction. You won't be able to do that with a spool, though, because if you add a TPU ring to the spool, you're increasing the diameter, and that's going to make this measurement off by even more. But yes, it looks like 100 millimeters is about 1 foot. That's crazy. Let's double check that. So 50 millimeters is 314. So 314 divided by 25.4. Yeah, 12.36. Would you look at that? I mean, that's just crazy that every 100 millimeters in diameter is equal to 1 foot in circumference. So a 100 millimeter circle is 1 foot in circumference. A 200 millimeter circle is 2 foot in circumference. And a 300 millimeter circle is 3 foot in circumference. What's the chance of that? It's actually kind of crazy that works out like that. Two completely, utterly unrelated measurement units. Because millimeters has nothing to do with inches. That's just crazy. Big Bad Joe, she's doing okay. Still not standing up yet, but, they're working on it. That's actually mind-boggling. I mean, what is my hair's going crazy again. Ugh, I hate when it does that. What is the chance of that? That millimeters would so perfectly line up with inches like that? So 100 millimeters is a foot, 200 millimeters is 2 foot, 300 millimeters is 3 foot. Oh, does it scale? What if I do a 500 millimeter circle? 250, because this is radius. 1570. 1571 divided by 25.4 divided by 12. 5.15 feet. So you're gonna start falling apart past 500 millimeters because this is getting bigger by 0.036, I think, per. But the fact that it's that close is just amazing. That's freaky. That's really freaky. So basically, it works up to 500 millimeters. I mean, it's not precise, but when you're measuring 100 feet, it doesn't matter if you're off a foot. It really doesn't. Not for setting up Christmas lights. It just doesn't matter. I want to see how long my driveway is. So I thought, okay, I'll get one of those measuring wheels to measure the length of the driveway. And then I found out that those measuring wheels are not exactly cheap. They're actually pretty expensive. So if you look up those measuring wheels on Amazon, $40. Now I have seen them as low. I have seen them as low as 25, especially if you order from AliExpress. But so far, 25 is the best price I could find. I have not been able to find. No, that's not quite accurate enough. I doubt that's accurate enough. Especially when you start going around turns. My driveway's not straight. Let's see. How can I show you without giving everything away? Hang on. Let's switch back to this. Well, that's interesting. It has part of my driveway mapped out. Isn't that weird? Oh, and it's got the back parts mapped out too. Would you look at that? And it's still backwards. That's not 44. Wrong information. This, they're right. The plot information was wrong. 48. What are you doing? Why would you do that? Why does it keep jumping away? What the fuck is going on? Every time I type a letter, it goes away. Something's being selected. It's like something's being clicked. Huh. I'm Groot. Why can't I pick? I can't submit. Now I can submit for some reason. Okay. So let's correct that one. I corrected this already. This should not be doing this. Report a data problem. Wrong information. This is what we want to correct. There. 44. Oh, it's doing it again. 44 Pinion Road. It's like something's being clicked. It's like highlighting, like it's... That is so fucking weird. I don't know why it's doing that. Go the fuck away. This goddamn little window won't go away. Are you fucking kidding me? I can't show you because I'll dox myself to the whole fucking internet. But it won't let me click this. Well, it did click it. It filled it in, but the window's in the way. I can't see anything because The little pop-up is in the way. I guess I have to refresh it. I don't know why it's misbehaving like this. Something's not right. Is there some other device connected? Nope, this is off. It's acting like the. Oh, maybe it's the keyboard. Okay. What is going on? It's just not working. There. This is not 4080. It's 44. What the fuck? You've got to be kidding me. Is this a joke? How the hell does that work? Thanks, Matt. Yeah, I suck at this. Okay? Why is it typing dollar symbols now? There it goes. Ah! What a nag. Okay. It's like it's like a key was being held down on the keyboard. If you ever hold a key down on your keyboard, you'll notice your mouse is going to start acting really freaking weird. Okay. Now there's a way I can change this. Do that. What are you doing? You better get out of my face, whatever you are. Or I will bite you. I know there's a way to change this. Oh, there is a way to measure distance. Measure distance. Looks like it's 172 feet. I wonder how accurate that is. And if I go to the house, 200 feet. I wonder how accurate that is. Isn't that interesting? It says it's 191 feet from my house to the road going around the one path. Oh, you made chess pieces? That sounds like fun. accurate that is. Let's find out. How do I undo this? Clear measurement. So from here to here, I guess I have to do it again. Measure distance. Here to here. Why out here? Why did you add that random thing? Yeah! Holy shit, that's accurate. My house is 76 feet long, and I just measured the house on here, and it's 76 feet. 75.54, but I didn't get it precise. Damn! That's kind of scary. I mean, that's genuinely kind of freaky how accurate that is. Oh, do we have a street view yet? Nah. Nope. They got McCall frontage road, but they haven't done our road yet. They probably never will. Huh. That's kind of freaky. Oh, wow. That guy's got a hell of a setup there. I didn't realize the kind of setup what my neighbor has. It's actually pretty impressive. Holy crap, this guy's got a lot of stuff. Holy crap, he's got a lot of stuff. Spying on my neighbors. Yeah, no street view from my street yet. Wow, he's got a nice property. That's a big property. That's well, it's 2.5 acres. Okay. That is scary accurate. So I don't need to. I'm gonna make the measuring tape anyway, just because I want to. But yeah, that's crazy accurate. I mean, more than accurate enough for my needs. That's for sure. Huh. Okay. So anyway, the idea is if you make a wheel like this, and you make a 300 millimeter wheel, although now that I know 200 equals 2 feet, I might be better off making a 200 millimeter wheel. Because then anybody with an Ender 3 or a Bamboo or a K1 or whatever, anybody will be able to print it. It's pretty much any modern printer can do 200 by 200. So make a 200 by 200 millimeter diameter wheel. You put two magnets on it, 180 degrees apart, and that's it. You 42. It's not showing me. Yeah, 42 is the property I was talking about. Really nice property. The house is all the way in the back. He's got that nice long road leading up to it. And he's got a whole big shop type get up going in the back too. That's nice. I wonder what all those little buildings are. He has animals. It's pretty clear there's animals going on there too. Very cool. And then you can see it's interesting. And then look at the guy 28. Boy, does he got a lot of stuff. It's all organized. It looks like he's got stacks and piles in all different places, but he's got all kinds of stuff. And this is the empty one, 26. I'm not doing nothing with yet. I wonder is 9. Is that whole entire 7.5 acres? Looks like about 7.5 acres. Or is that separate property? I don't know. Heathen Industries? What is that? Painting and sheetrock. Okay. Huh. Yeah, 42 is like mine. Lots of trees. I like the trees. He's got more trees than I do. What do you mean some stuff going on? Are you trying to imply more into that? I'm not sure what you mean. I don't know them personally, but I've met them in passing a few times. They seem like nice people. Yeah, but they have me and my neighbor's house swapped again. Yeah, I'm probably going to owe more money for taxes. The it turns out that our plot descriptions were reversed, and I guess during an audit last year they tried to correct that error in our descriptions, and instead they made it worse. They completely swapped all of our information. So I got his tax bill and he got my tax bill, and it was all kinds of weirdness, which apparently they're fixing now, and I'm waiting to see if I owe any money. We'll see how that happens. Hey, I got that screwdriver ring too. The $4 one, the black one, appears to be gone. The postal description says delivered, left at front desk. What front desk? So, here, I'll show you. This is kind of funny. Oh, this one has a street view. That is not. Is that correct? Yes, it is. Would you look at that? Let's see here. I believe that was AliExpress, I think. I really like the new hey Jerry. I like the new USB lithium line that Ryobi has. Basically they do what a lot of other people do. They wrap an 18650 cell in a proprietary case. Um, um, and then they sell it for 10 times what it's worth. It's like, come on, be reasonable, people. Just, do you have to screw people for 18650 cells? I mean, come on. Stop being dicks. What are you gonna do? So one thing I want to try to do is eventually I'd like to get one of those tools just because I like Ryobi. But more importantly, I want to reverse engineer their case and design my own version of it. Hang on. I really have trouble doing two things at once. It is not easy. So, I wanted to see how cheaply could I duplicate what um how cheaply could I duplicate what Ryobi is doing. So I guess before I switch screens, let me bring that open too. Ryobi USB HIUM screwdriver. There it is. Yeah, that's why I couldn't open up a new window too. The key was being pressed on the keyboard. I'm betting you it was this right-hand shift key. Would you stop it already? Come on. I can fix that. Hang on. We're going to lose the stream for just a second. Wow. Okay. Is that better? Let's switch to desktop view and bring up the browser. So, this is their USB lithium line. I love the idea of it because this is basically just an 18650 cell wrapped in a case. And not only that, but you can charge it directly by stuffing a USB-C cable into the end of that. And the new 3 amp hour batteries are bi-directional. So you could plug like your phone into the battery directly and charge from it. So it's a really nice idea. But basically, if you remember the Black & Decker VersaPack tools, they're wonderful. I love them. It was poorly executed because they didn't make enough gadgets. But the idea of it is fantastic. And you can still get those batteries dirt cheap. So eventually someone's going to knock off these batteries because they're stupid expensive. And I'm going to knock them off. As soon as I can afford to buy one of these, I'm probably going to get the... right now I can't afford anything. But I'm probably going to get this one. The $50 kit that comes with the swappable heads. Because that's just like a really nice little kit. But $30 for this is too much money. It's not even that great. It's relatively low torque. So I was wondering, how cheaply can I do this? Well, you'd be surprised how cheaply you can do this. This says 15, but remember, these prices fluctuate all the time. Okay? So I bought this for $4.36. It's gone. I have no idea where it's at, and I'm probably never going to get it because UPS delivered it here. Where does my mail come? My mail comes here. Okay, that's the cluster box where I get my mail. And this is what the delivery notification says. Delivered to front desk reception hall mail room. Do you see a front desk anywhere? I mean, do you see a fucking front desk anywhere? I don't. Where the fuck did it go? I mean, come on. You know, I can't expect USPS to do what UPS and FedEx do, where they take a picture of the package delivered. First of all, they should require them to take that picture further back. No close-ups. Because sometimes you can't tell where the hell it is because the picture's too tight. But more importantly, USPS can't do that. They just can't. I mean, on that Monday when this thing was supposed to be delivered, my post office delivered 5,000 packages. There's only 6,000 people in Edgewood. Okay? So they can't take a picture of every package. But you know something? They have to scan every single goddamn package. And that scanning device is live, meaning it's online when it scans. Because I was sitting here, I was parked right there. I parked my car right here because she parks her car up here so she can open her hatch and fill in all the boxes. So I was parked right there, and within seconds, I got the notification that your package is delivered. You know, when she scans it and it marks it as delivered. And I wasn't there the day the screwdriver got delivered. It was done early. So why not geolocate? Okay? Whatever device you're using, it's a cell phone. Okay, whatever it is, it's a cell phone. It's a PDA, it's a cell phone. So geolocate every scan. attach GPS coordinates to every single scan, so that when something like this happens, they could look it up and say, okay, where was the employee when that scan was done at 9:52 on December 13th, 2024? So that we can find out where the hell my package went. Because I can't get a refund. I mean, for USPS to file a refund, the shipper would have to have paid for insurance, and they didn't. And the shipper's not going to refund me because they're going to check the tracking number, and it's going to say it's delivered. Too bad, not our problem. So I'm just screwed out of the screwdriver. I mean, they did something wrong, and I'm screwed. But yeah, you can get these things dirt cheap. So, USB screwdriver. You just type USB screwdriver. Why is caps lock on? And you could find these things stupid cheap. Stupid cheap. I don't want these. I think I typed 4 volt. Here we go. Oh wow. Oh wow. No, that's for bits. This is for bits. Yeah. It's $2.07 for the stupid set of bits. I hate when they do that. It's $12 for the screwdriver. But you can get these cheap. I paid $4 for the black one. It just went to the wrong place. And I paid, you have to hunt around, but I paid $5.30 for this one because I wanted a pink one. But this is actually really nice. I mean, just surprisingly, really surprisingly nice how nice this is. It has almost every single feature the Ryobi one has, and it's probably just as strong as the Ryobi one. It comes with a bit. Okay. Now here's the cool thing. I'm going to work on that. I got to design it. The giant bulb is available at Home Depot. You go. I have a window. I'll show you. Desktop. Here we go. $25. It's a timer base, so it takes D cells. And so what you do is when it gets dark out, you turn it on, and then it runs for 6 hours, then turns off for 18, then on for 6, off for 8. It's one of those automatic timer circuit ones, and it's basically a big giant 3-foot tall C9 Christmas bulb. So later today, we're going to make one. Well, we're going to design one. We're not going to make it because that's going to take a while. But I can't afford to buy them, so I'm going to build them. And so this does everything the Ryobi one does. It's even got features the Ryobi one doesn't. So for example, if you lock it, it doesn't run the motor, but it lets you turn the flashlight on. And I can feel it. It's not engaging the motor. So it's only turning on the flashlight. So you can actually use this as a flashlight. Okay? And then, of course, forward and back. USB-C port. Alright? There's a 2 amp hour 18650 cell inside of here. And it's even got the rotatable handle like the Ryobi one does. So you can turn it into a stick screwdriver, or you can turn it into a pistol screwdriver. And it was less than $6. I paid $5.30 shipped. Okay, it only took a week to get here. And so my idea is, well, can I open this up, gain access to that cell inside, and make it removable? So maybe turn this into a hatch that I can screw on or whatever, and then make it so I can swap out and replace that 18650 cell inside there. And but this does everything it does. The only thing this doesn't have is it doesn't have a swappable battery. Otherwise, this is everything the Ryobi is. It even comes with the USB-C cable. It comes with the bit. It's a USB-C port, so it's not no freaking barrel jack or micro USB port. And it's got the locking. It's forward and back. It's got plenty of torque. I can't stop it. And it's got the pistol grip swap out to turn it into a straight screwdriver, or to make it into a pistol grip screwdriver. And but for a hell of a lot less money. Actually, I want to play with this today, because one of the things I want to do is I want to take this thing apart. It's amazing how expensive these jumper boxes are now. I mean, just insidiously expensive. So I got this jumper box, and oh, this actually still works. This actually holds a tiny bit of charge. It still lights up. But the gel cell in here is bad. And the problem is, and this is a nice one too. I think this one stopped working properly, but this one has a pop-out jack. So you got a plug here. It's just really hard to get out. So you have a 110 volt socket. So you just take your extension cord and stick it on there, and it recharges. So the charger's built in. You used to be able to get these for $20. Now these things are $110. It's like, what? It's a fucking gel cell with a little LED light. It shouldn't be $110. You can get one for $40 on Amazon. I linked to it last time. But anyway, I want to take this apart and try to replace the cell, because I'm pretty sure the cell should be very cheap to replace. This where the flashlight will come in handy. It is a Phillips bit. So one toolkit that I got was this one. It has all the long bits. It's got Torx, it's got hex. So it's got all the bits I need. Let's see, where is my Phillips bits? Right here. So I needed these long bits to reach inside things like this. Now this should fit my 3D printed. Perfect. Oh yeah, here we go. I can crack them all loose. You guys can't see what I'm doing. I'm cracking all the screws loose, and they all crack loose. That came in handy. That worked. It's a little loose. These fit a little looser than the other ones. That's annoying. I spent a lot of time making that nice and tight, but apparently there's a lot of tolerance between these bits. So now we switch over to the screwdriver. That's loose. Tighten. The struggle is real. You guys can't see what I'm doing. I'm just loosening all these screws. There's another screw. Whoop, lost one. Inevitable. Like Thanos. You're always going to lose screws. Should be able to drop these out. Leave those on. Replacement fin for my lawn jet using TPU. Yes, your stock CR10S Pro can print TPU. Shorten your retraction distance to like 2 millimeters. Slow down your retraction speed to like 10 millimeters per second. And then slow down your print speed to 20 millimeters per second or slower. Basically, you got to go slow, because what's going to happen is if you go too fast, the filament's going to bend in your filament path and it'll escape. If you go slow enough, you give it a chance to push the filament in without it bending. But that's basically all you got to do, is just go real slow. As long as you go slow enough, it should be okay. You might still have a failure here and there. Just slow down a little bit. You'll be fine. Okay. What am I attached to? I can feel it attached to something. Is there a screw still attached? Yes, that screw right there. But that's the thing, just slow down. It's surprisingly effective. Here it goes. Okay. It is. Just a freaking gel cell. Oh, I can detach this. Nice! This is serviceable! That's awesome! There's the charging circuit. So maybe I can actually look over that and see if it's okay. But there's your charging circuit inside there. And this is actually got a plug. So I was able to disconnect the charging circuit and the fuse is not blown. But yeah, it's just a... Oh, the handle pops off. But it's just a gel cell. So I just gotta, get another gel cell this size. Of course, that's going to require a wrench. Put the keyboard over there. It's on here, I guess. It should just come out. I doubt there's anything holding it in. Nope. It just sits in there. So what I need to do is loosen these connections, replace this gel cell. Is there any kind of markings on it? It tells me, here it is. Let's see here. WP7 28 watt. No other details though. WP7-12. Is there anything to this, or is it literally just jacked straight in? It is. The 12 volt part is literally just the battery. There's no electronics to this. The only electronics is the switch, the 12 volt socket, and the LED light. Otherwise, there's no electronics in here. The gel cell is connected directly to the clamps. So you could literally just take this gel cell and these two clamps, and that's all you need. So I could make a really compact one of these. Huh. So what would one of these gel cells cost? I bet you it's a lot less than $110. Let's see, WP7 dash, was it 12? I think it was. WP7-12. See if that comes up. Yes, it does. $20. That's an ML7-12, but I bet you it's the same damn thing. Technically, this is it right here. WP7-12, 28W. That's it right there. It's a 9 amp hour gel cell. Let's see if the dimensions are the same, because I'm not paying $37. Does it tell you the dimensions? Here it is. 634. It's slightly different, but that should be fine. So $20. I'm going to add that to my cart for now. I don't have any money right now, so I can't buy anything, but I'm going to add it to my cart just so I can remember it. I might as well check to see if there is an actual 9 amp hour one. I might try a lithium iron phosphate battery just to see if it works. I mean, I know it's going to draw more amps than the BMS can handle, but it only draws those amps for a few seconds. I wonder if you can get away with it. Like, it's only $25. I have them. I don't need to buy them, but it's only $25. But the problem is this 15 amp BMS. I don't know if that's enough. Like if it'll let you start the car before it kicks. Here's a proper WP7-12, but it's not prime. I'm almost certain that other one will fit just fine. How you doing, Donk? Here's one for 18. Good, good. Yeah, I'm 99.9% certain that 0.3 inches isn't going to matter. You guys cannot see what I'm showing you. So, yeah, 20 bucks. This is technically the correct size. WP7-12, 28, 12 volt. That's exactly what's inside my unit. Those numbers. But I'm pretty sure the ML7-12 is, it's going to be exactly good enough. It'll be fine. It's just a jump box. I think I am going to. The question is, do I want to risk burning up the BMS in one of my batteries? But I wonder if this would be enough. Because if I put a lithium iron phosphate battery in there, it'll last forever. Like 30 years from now, you could find this thing at a yard sale and it'll work fine. Because the lithium iron phosphate is just never going to die, ever. Never. It'll never fail, ever. I mean, it's good for thousands of cycles. And how often do you use a jump box? Hardly ever. I'm really surprised no one's just made a bog standard jump box with a decent. See, now the reason these are so cheap is that these are low grade cells. So they can't put out tremendous amps. And for what most people want to use these things for, they don't need to put out tremendous amps. And even if my battery, oh, look at this. Even if the battery is a tiny bit thicker, that's okay. This actually has room for a thicker battery. It's got these standoffs here. So if I shave them down a little bit, I can fit a thicker battery in here. Which means I should be able to put, that $20 battery will be just fine. Okay. Yeah, that just sits right in there. And there's wiggle room too. This can move around a bit. But yeah, it's too bad I can't use regular terminals. But yeah, these are just literally plugged directly into the clamps. If you look, see? This is the big thick wire, and it goes directly to the clamp. And the same thing over here. See? See the big black wire? It goes directly to the clamp. It doesn't go through a relay, it doesn't go through a circuit breaker, nothing. It just goes straight to the clamps. Which is why you really don't want to short these. This is for your 12-volt accessory outlet. This is for your LED light. I'm surprised it needs all that for the LED light. Oh, that's also the charging board, I think. Yeah, I bet you that's the charging board as well, because the charging board can't connect here. This here is the charging board. This goes to the inverter board on the transformer board on the back of the unit, and that goes to this board here, not to this. So this is the charging board here. This is the circuitry that controls the charge. And then this is probably just the inverter. This just converts the 110 volt in to the 14.8 volts. And then that 14.8 volts goes to this board. And the charge controller then uses that to charge the gel cell battery. So worst case scenario, I can put a different charging board in there if that one's bad. And then just put a jack on the back of this. It'd be interesting. I should be able to connect a USB-C to this. It shouldn't be that hard to put a USB-C port on the back of this and have USB-C charging. I might do that. Boy, I wonder how. Why does this have 4 wires? What's the purpose of the 4 wires? If it's just DC coming out of this, why does it have 4 wires? I don't know enough about what I'm looking at. I mean, there's coils here, so I'm guessing this is a transformer. But why does it have capacitors? Why is this so complex? Unless part of the charging board is on this. This is a single board, single surface board. It's not a multi-layer board. That's why it's this plain color and these parts are just sitting on here. So it's not an SMT board. That's an SMT board. That's a multi-layer board. That's a single layer, just a standard pass-through board. There's diodes that controls direction, so that's going to be your bridge rectifier right there. Those diodes right there and this are probably your bridge rectifier. Is that a fuse? That might be a fuse. I'm not sure what the capacitors are for, and I'm not sure what the second coil is for. Well, okay, this is probably rectifying the AC into DC, and then this is probably turning it from 120 volts DC, because the rectifier is going to make it DC. And that's probably, this stuff is probably changing it from, because you're not putting 110 volts through that. That's for sure. So this likely is the full bridge rectifier to turn the AC into DC. And then this is likely transforming it down to the 15 volts that's needed for the charger. But then, why 4 connections? Unless some of the logic is on the other board as well. But then, what's all this logic for? I mean, all this is a 12 volt LED light, and all this is a 12 volt power socket. So what's all the logic here for? If there's logic here, why does this need 4 connections? I don't have to talk to somebody about this who knows more what they're doing, because I would love to make this USB-C. And I just might try to put a, well, I guess it'd be easy enough. All I'd have to do is take these 2 connections, put them on one of my lithium iron phosphate batteries, and risk blowing it up. You know, maybe I'll blow it up. I'm too loud here. There we go. Maybe I'll blow it up, but if it works, then I could put a lithium iron phosphate battery in here, and this will last forever. Very, very interesting. I do have sockets. Oh, it's in the car. I have a socket set in the car. Okay. I like how serviceable this is. I wish more manufacturers would make things serviceable like this, with plugs, screws. Okay, so I can repair this for 20 bucks. Well worth repairing. Oh, the screw's sticking out. That's why. But yeah, I want to repair that. I like my jump box. I like how small and compact this is. It's the problem with the lithium ones is that you can't run the car off them, because they're not designed to keep providing power. Let's get this put back before I forget, and then I lose bits because I'm an idiot. Don't be an idiot. Wait, it's hard to put the bits back in here. It's annoying. Well, if I put it in the other way, it would have been easy. I was making it hard, and I didn't need to. But yeah, that's a hell of a lot cheaper. And even if the cell in here is crap, for $3, you could buy a quality cell and replace it. In fact, let's check it. Let's see what's inside this. Because I'm wondering, can I 3D print a new shell? 3D print an enclosure to fit in this to allow me to use the Ryobi batteries in here. Use my 3D printed handle. Pop these open. It'd be easier to pop it off the handle now, so I can just spin it. Will it let me take it apart, though? Believe it or not, that's one thing that's nice about Chinese products is a lot of them are surprisingly serviceable. You can take them apart. I can actually see a movement to go, for people to prefer the Chinese junk simply because it can be serviced. And so you can just modify it to make it not junk. It'd be massive. It's just, I hate the proprietary lock-in. Like, come on, just, do you have to be so consumer hostile to make a profit? I mean, why choose to make your customer your enemy to earn money? Oh yeah, that pops right off. And look at that. It literally is a switch, a charging circuit, and an 18650 cell. So the core modification I would make to this unit here would be to maybe do a little bit of cable rerouting here so that I could make this battery replaceable. And this might actually be legitimate. It says 1300 milliamps. That might actually be what that battery is. So they're not lying. 5 watt hours. But the one change, this battery is welded on, so it's spot welded. And then this is your charging circuit here. Boy, that is a simple charging circuit. There's just not much to that. See, that's your USB-C charging circuit right there. And it's just got the LED literally just shoehorned in there. You can tell when it's charging. Otherwise, it's just switch. Oop. Don't do that. But yeah, the only change I would make is I'd like to see a door here, and then make this battery replaceable. So replace this battery with a socket to hold this battery. So expand the space a little bit, put a socket in there, and then put that same cell right back in there, but without the soldered on wires. And this way you could just open a hatch and replace the cell. That'd be nice. Yeah, this whole thing pops right off here. You just have the wires running into the end there. Very nice. They even have more wires than you arguably need for something like this, which just makes it more durable. I want this to go in. There it goes. Got it. I like serviceable. I like serviceable a lot. It's like, why can't more manufacturers do that? That's what we need. And the problem is, it's all profit driven. So if a manufacturer does try to make nicer equipment, they'll just get pushed out of the market by profit points, by profit margins, and that just sucks. That we design our system like see that now people are going to call me a communist for this, even though they're stupid because communism doesn't exist. There's no such thing as communism. Anybody that thinks communism exists doesn't know anything. But it's just a slur word. It's just something they call you a name when you don't agree with them. But this is where government should come in. This is where, why do you think all of our phones have USB-C? Because the European Union told the manufacturers, you're not allowed to sell a phone in our market unless it has a USB-C port. Use a standardized port. Hang on, this is important. Hello? Yes. Yes. For Friday, yes. It's either, yeah, something like that. 2130 Eubank, I think. Um, it's either 2130 or 2140 Eubank. I think the appointment's like noon, but I'm guessing you guys are doing it earlier because you have the transporter there and stuff. Mhm. Yeah. The paper I got said 1240. Yep. But on Michelle said 1030. Yeah, Eubank Avenue. And I assume that was because you guys have to load her up in transporter and stuff. But the paper I got in the mail from the place said 12:40 p.m. the 20th. No, I don't. Pretty sure. Let me check maps. It should come up as an actual place if it's the right address. I think it was 2130 Eubank. 30 Eubank Boulevard Northeast. Yes. And because it was she couldn't make the last one because they had the wrong van, they couldn't fit her, but now they've realized that she fits in a regular wheelchair. Um it was supposed to be, if I remember correctly, it was supposed to be to get her back on birth control, but progesterone without estrogen, so she doesn't get the blood clots again. Without the estrogen, so that she doesn't get the blood clot problem again. That's my vague memory, so obviously they will hopefully know better. And remember, if she misbehaves, just put the taser at the bottom of the bed. I like teasing her. She behaves well. Also, something else. I was there one time when they tried to do the physical therapy, and I noticed that one of the limitations might be psychological. Something important. Michelle is developmentally challenged, so she's. Well, I mean, we don't use that word anymore because it's a derogatory word, but she's mentally retarded. So she's not dumb, she's got the intelligence of an adult, but she has the maturity of a child. And so I don't know if that changes how they might encourage her with the physical therapy. Because with her, if it hurts, she just doesn't want to do it. It hurts. And and like you and I would realize, okay, I have to deal with the pain if I want to get better. But with her more childlike mentality, she might just be like, I don't want to do it. It hurts. I don't know what the correct procedure for that is. I tried to encourage her, but I didn't want to push her because she might just shut down if I try to push her. So I don't know what the correct procedure for that is, but let them know. Maybe they know what the procedure is to handle people like that to give them the encouragement they need to do what they need to do. Okay. Yeah, I imagine once they understand that there probably is a procedure in place for that. I just don't know what it is. Okay, thank you very much. Bye bye. That was Spanish Trails where Michelle is. So that was important. take that. Finish putting this back together before I break it. Is there no text here? Am I missing something? No, looks okay. Yeah, looks okay. So what are you doing today, Dunk? Yeah, I like serviceable. I wish more companies would make more serviceable components. Now, at first, I was annoyed. I was like, why don't they just make the thing take an 18650 cell? But now I also realize why no U.S. manufacturer tends to make things that use 18650 cells. And I can't argue with this. It's a valid reason. 18650 cells are dangerous. Still works. It's a naked lithium ion cell that is capable of bursting into flames. And bit back before I lose it. There's no point in having a tool case. Oh yeah, it inserts much easier from the bottom. I tried inserting it from the top, which was really hard. But if you just insert it from the bottom, it just slips right in, no problem. I can actually show you why manufacturers, especially in a country as litigious as the U.S., why would you do that? So here is why you're not going to see manufacturers use naked 18650 cells. Liars, fake. May or may not be lying. 3300 milliamps is very difficult for an 18650 cell unless it's a naked unprotected cell with no protection circuitry. Liars, frauds. Is a naked cell. That's not impossible, but it means there's no protection circuit. Okay? This one theoretically should be accurate. This is about right. 2500 to 2800 milliamps. 2600 milliamps. That's probably correct. Liars, frauds. Probably lying, or it's a naked unprotected cell. Okay? I mean, this one, unknown. Who knows? It doesn't say. Liars, frauds. Naked unprotected cell. You know, well, what's this one here? We don't know. What's it say? 2500 milliamps. Theoretically, that might be valid. Liars and frauds. Liars and frauds. Maybe this is valid. This is a double A. Okay? There's no such thing as a 9900 milliamp 18650 cell. There is no battery chemistry known to man that will allow you to fit 9900 milliamp hours of capacity in a rechargeable 18650 casing. It just doesn't exist. There's no such thing. Half the time, these are 1 amp cells. They're not even 1,000 milliamps half the time. They're just watch BigClive.com. You'll see what I'm talking about. He just pulled apart an 1860 cell that had like nothing in it, had like no electrolyte in it. He measured it at 130 milliamp hours. They put as little chemical as they could in there to make it actually function, but it had basically no capacity. And the problem is, if you attempt to use the cell for what they claim its capacity is, there's a chance that thing's gonna fucking blow up and burn your house down. And does Ryobi want to put their entire company at risk for a naked 18650 cell? No. And even if a person replaces the cell with an off-brand cell, they're still going to sue Ryobi. So that makes sense why manufacturers would do things like build the cell into the unit or make a proprietary battery. because that allows them to control the product. The problem is they're charging $40 for a $10 battery. That's a lot of money. Come on. There's just no reason to charge that much for it except greed. I mean, and then the tools are too expensive. They're charging almost as much for a 4-volt electric screwdriver as they do for a regular screwdriver. I mean, what do they charge for the, like this screwdriver kit here? Can you guys see this? No, you can't. There we go. This screwdriver kit here is $30. That's a lot of freaking money. There's just no reason for this to be $30. Or if you're gonna charge $30 for it, make it nicer. You know, give me 10 Newton of force out of this instead of the 3 that it puts out. All right, give me a double bit holder on the bottom here. You know, include 2 batteries. You know, and stop with this fucking 2 amp hour shit. You make a 3 amp hour cell, shut down the 2 amp hour factory line, and only make 3 amp hour cells. Streamline your production instead of making the batteries a add-on to charge them an exorbitant amount for the capacity battery that should have been included with the screwdriver. You know, otherwise this is pretty good. It's otherwise pretty good. It's a little bit underpowered. It's a little bit underpowered big time. I think this is stronger. Although it won't last as long. You know, how about a little bit of torque settings on here? How about give me a little bit of torque options, even if it's just 1 or 2. You know, anything to justify this $30 price. I mean, if this thing had, you know, the 3 amp hour battery included, the tool also had a USB-C port so that you could charge it while the battery was inside of it. Maybe even, you know, make that USB-C port bi-directional. Why not? It'll cost you next to nothing. Have a little bit of torque settings on here. Have a double bit holder. Learn from this manufacturer who came up with this wonderful idea where when the tool is locked, the flashlight works. The flashlight only works when you activate the wrench, and it only activates for a short time, like that. Okay, well with this one, all I have to do is lock it, and now it's a flashlight. And that's from a $6 screwdriver. Okay? That's including shipping. Okay? And then, I mean, well, the Ryobi's better. How? Okay, it's got a bit holder. I'll 3D print a 5-cent piece, and I'll put a bit holder there. It turns into a stick. So does this. It's USB-C. So is this. Okay? It's the same thing, except this is 6 and that's 30. On sale. It's normally 40. What's their normal drill cost? $60. And that comes with the charger and the battery. So for $60, I can get a full-size 18-volt drill with a full-size 18-volt battery and a full-size 18-volt charger. You're considering the value of the 18-volt battery and the 18-volt charger, you're paying about the same price. That doesn't make any sense. You know, here's $49. Here we go. Here's one on sale for $49. $49, 18-volt drill with battery and charger, and this one has torque settings 10 times the power. I mean, it just... let's see, do they have a tool only? That's a hammer drill. That's a different beast. Now, to be fair, this is their freebie tool. This is their buy-in tool. That's the that's tool only, but that's their 1+ HP brushless version. That's their high-end version. I mean, even their old 4-volt screwdriver is only $25. I think that's too much money. Right? That's basically that without the replaceable battery. It's the same thing without the replaceable battery. I mean, just come on, Ryobi. You're supposed to be the good guys here. Stop ripping people off. So that's what us 3D printing will do. We'll force them to make it affordable, whether they want to or not. So one of my plans is to once I manage, oh, you guys couldn't see what I was showing you, of course not, but you heard what I said. But one of my plans is to gut the bottom of this and put a socket in here to allow this to take the 18-volt or the USB lithium batteries from Ryobi. Because if you look at the actual batteries, this is the cool part here. USB. I'll switch screens in a second. Where is the batteries? Here they are. Do they show a picture of the actual socket? It looks like they might not. More pictures. Do they never actually show a picture? They never actually show a picture of the contacts. But someone on Google has. So we'll just find a picture. Come on, I know somebody's got a picture. Why do you have to be a pest? Just show me a picture of the other side of the battery. Here's a video. I can just play the video and then I can pause it when he flips the battery around.
So this is going to be an upgraded version of the 2 amp battery that you guys know that other than power another device. So the cool thing about the new 3 amp, so the new thing that we can do now is we do have a battery status indicator. So this is straight out of the packaging, so it is empty, so it is showing red. I have an orange indicator, an orange, I believe. Right, so when it's half, and then there's an orange, I believe. Right, so when it's half, so it is. Now is we do have a battery status indicator. So this is straight out of the packaging, so it is empty, so it is showing red.
There it is. Okay. So on the other side of the battery is these contacts. And only 2 of them are actually used. This is probably either temperature or no balancing, single cell. But I know you can connect to just this contact and this contact, and it'll just output the 4 volts that's inside the battery. So all I have to do is design a receptacle to accept this battery, stick it in here. Oh, you're going to lose your USB-C port. I don't care. The battery has a built-in USB-C port. So I could theoretically, I should be able to turn one of these $6 screwdrivers into a Ryobi USB tool. I also want to make a 3D printed version of, well, some 3D printing of the tripod area light. So this right here. I think this is an 18-volt version of it, but I think they have a smaller version too. But this is just nuts. This is the cheaper one. Yeah. They have a new one. But basically, it's an area light. So you have a tripod and an extendable arm and a light on top. They have a bigger one out now. It's a new version. It's this one right here. Can you guys see what I'm showing you? Yes. There it is. There it is.
So as you can see right there,
nice tripod. Easily 3D print that base. Okay, let's try to find a good shot of the head. Yeah. He only has 2 lights on there. But that's the whole idea. The whole idea is you can extend this tripod and you have these lights on the end of it. And it could light up an entire area. That's the idea. Hang on, let me get there. It is. So the idea is you set this tripod up and it lights up the entire area. They want $200 for this. That's a lot of freaking money. That's a whole lot of money. And that's not that tall. How tall is that? Does he have a link to it? Yeah. I wonder if Home Depot has an affiliate account. I'll have to check that. So yeah, 360 degree, 18 volt, 1 plus. I already have an 18 volt socket designed when I made my little 12 volt light. How tall is it? 35 degree, 4 brightness, 7 foot height. So that's 2 meters. That's only 2 meters. It's a little over 2 meters. That makes it a lot more affordable because I can get telescoping poles pretty cheap at 2 meters. We don't want a skinny one like this. We want something a little bulkier. Here we go. This is a pretty decent looking one for $10. Can I get cheaper? I actually like that. And I saw a carbon fiber one. Actually, a 2 meter flagpole would work really well too. Here we go. $25 for a really nice carbon fiber one. That's 10 poles. We don't want to dick with that. Wow, this one has the tripod. Okay, so all we would have to do is 3D print the battery holder and the socket. So for $14, we can buy this tripod. Or if you really want to go cheap, for $9, we can buy this monopod. What's it made? 1.5 meters, 2 meters, $12 for 2 meters. That's also 2 meters. What's the difference? Why is that one cheaper, but it's not? It's thicker. Why can't I order that one? It's weird. Bet you we could do it even cheaper. Actually, this is pretty nice. Does that come with all three? Two-meter tripod, 2.8 meter tripod. Okay, this is including both. Okay, so it's what's the difference there? What was that? I just saw something that said $9. That's $9. Well, there you go. There's a. Is it 2 meters or is it 3 meters? That says 2 meters. This one must be the 3 meters. So $13 if you want 3 meters, $9 if you want 2 meters. And then we can easily 3D print a tripod and 3D print a mount for some LED lights. With the appropriate 3D printed battery socket, you can design this for any battery chemistry you want. In fact, it might be interesting to design one that can take all the different batteries. Just because then I can say, okay, who's got a battery? What kind? I don't care. Just plug anything into it. That'd be fun. But oh, nope, that's expensive. I mean, you do have these, but I don't know how strong these are. These tend to be pretty weak. But you can get one for $5. $4 if you want 2 meters. $5 if you want 2.5 meters. And 2 meters would be plenty because you're going to get half a meter out of the tripod, and then another half a meter out of the light mount on top. So yeah, might as well go to 2.5 at that point. Question is, how strong is it though? Is that just a? Oh, it's literally a flagpole. Scale. How big is this? How thick is it? Ugh. Might be better to get the 1.2 meter $2 one just to play around with. Either way, a 2-meter one is $4. And then we would just have to design a mount. So, LED area light. We need 12 volt. You're going to want to use automotive parts, definitely. It actually wouldn't be that difficult to design a socket to hold a bunch of these. Put like 10 of these around a 360-degree circle and create your own version of a 360-degree area light. That would work pretty well. The trick is to be big enough to produce the light we need, but small enough to be foldable, packable. These would be perfect. These are surprisingly bright, the larger ones. And then also not consume so much power that it drains your battery in an hour. Let's see, LED cob. Oh, something like this could work well too, because I could print a circle. I could print a ring and put one of these around the ring using a naked cob like this. And a 300-millimeter ring would be 3 feet, which would be about a 1 meter length of cob strip. Although I think we'd be better off using something like this and using a polygon shape. And that's only $3. There's white. And there's 20 of them. So that's 40 watts. So these are usually 2 watts each. It probably tells me somewhere. 1.5 watts. So that's going to be per. So that's a half a watt per emitter. So each of these is half a watt. So it's 1.5 watts per. So that's 30 watts. So the only parts I would have to purchase would be $3 for the LED light. $4 for the telescoping pole. And you would also need some nickel strip for your socket, although you could just buy a socket too. Let's see here. Just to rub it in their face. That's a power tap. Oh, that's an inverter. That's why that's so expensive. I know these are dirt cheap. And here's $5. That still seems like a lot of money, doesn't it? Although actually, it's pretty nice that it has a plug. This one's going to have a shipping charge. Yeah, $5 shipping charge. It's actually not that bad. I especially like the fact that it has a switch. That might be worth the higher price. Here's $7. That's $1 cheaper. This one's $5. Is it more money for the one? Yeah, $6.73. It's only slightly more. So this is nice because it'll snap right onto your rear battery. It has a switch and it has a fusible link. So that's what I would use. So now, purchased components, we are at $7, $8, $9, $10, $14 shipped. So for $14, you don't even have to print the battery holder, or if you want, you can print the battery holder and buy a switch. This point, for this price, I would rather just buy the battery holder. And it's got the switch and it's got the fusible link. That's just nice. That's really nice. Yeah. And it looks like it comes with the Wagyu style connector to connect to your wiring going up to your light. And it looks like it comes with extra fuses too. So you buy one of those, you buy one of these, and you buy one of these. And then you 3D print the head to hold this. So this is 20 pieces. So how do we want to wire that? I would probably have 4 right near the center pointed straight down. And then I would probably have, let's see, 4 is going to be 16 left. Then I would probably have 6 on the next ring, angled 30 degrees. And then 10 on the final ring, angled 60 degrees. That should give you some really nice illumination. If we have time today, because I got to stop at 2:30 because I want to go get the veggies from the Roadrunner. But maybe we'll if we don't do it this week, I'll do it next week because I want to do the Christmas light first. So that's 3 projects I want to work on. I want to make a tripod battery-powered area light so that I can, you know, not spend $200 on the one from Ryobi. I want to make a measuring wheel. What's that? That's not here. I could find this later, so I'm not worried about finding this. Let's close these tabs up. We don't need that. We don't need that. I want to work on making one of these, but we'll do that next time. Because right now I want to work on the Christmas light. I want to make this. So these are kind of going crazy. If you look these up on YouTube, there are people, you know, converting these to plug into 110 volt. There are people plugging these into 110 volts. They basically rip out the LED light, drill a hole, they put a light socket in there. And, are you guys there? I haven't seen anybody post anything in a while. Is my text broken? Doesn't seem like it. It seems like it's working. If somebody wouldn't mind saying something, just... There you go. Okay. Is the audio still in sync? So these are approximately 3 feet tall. Designing that base is going to be pretty easy. I found a basic shape for the C9 bulb. I think it's a C9. Could be a C7. But we're going to assume it's a C9. Now what we're going to need is these to put a regular bulb. Now the nice thing is you can get 12 volt E27 bulbs. Let's check and see what they run. 12 volt E27. Yep, here's 12 volt E27s. That better not be one. You'd have to be insane to pay $10 for one. Wattage is too high. I need more like 1 or 2 watts. Oh my god, that's for one. That's insane. Who would be dumb enough to pay that much? You'd have to be dumb. This is what you want. Even that's a little expensive. But at least that's 6 of them. Warm white or amber. You don't want amber. You want warm white. At least you get 5% coupon. But this is what you want. You want the 1 watt, warm white, 15 watt equivalent, E26 base. So you would use something like this. You would want something like this. The advantage of this is when you 3D print your primary plate to hold this, all you have to do is put the correct size hole in your print. Then you can just screw this right into it and the wires dangle out the back. And then you just buy like 15-foot extension cords. When you add the little bit of wire inside, let me know if the audio gets annoying. I'll reset OBS again. I got to figure out why OBS is causing that problem. I think I encountered this before and there is a way to fix it. I don't know though. You just cut your extension cord, attach it to that. You attach both ends to that. And then you let the extension cord pigtail hang out the other end. This way you can daisy chain the lights. But for something like a Christmas light, you do not need more than 1 watt. It's plenty. You could go 2 watts if you want it to be brighter. So, you should be able to get these in 2 watt variations. Or if you want stupid brightness, you got 4 watts here and you got 6 watts. But that's kind of crazy to me. I just don't see a reason to need that much. Now, the only problem with these type of 12-volt bulbs is that if you accidentally plug it into a AC socket, it's dead. You're gonna have a little bit of fireworks. You want to be careful. But any other cheaper alternatives? 6 watts. 6 watts is a lot. There's no reason to run 6 watts into one of these. That's like a 40-watt bulb. You do not need a 40-watt bulb in a light like this. You just don't. Here's 3 watts. That's a good in-between. Run 3 watts if you really want more light. But I really do think 1 watt is probably plenty. So, you need that. You need these. And you need extension cords. Your best bet is probably a 15-foot extension cord. 15-foot extension. Let's see here. Anything cheaper? Oh, I wonder, can you get... Oh, and this is what you need for the counter as well. Can you get extension cord on AliExpress? You'd have to be stupid to pay for that. Well, there's a standard 2-prong, just so end-to-end. But it's got shipping. Oh, it's only 60 centimeters. That's not 15 feet. It's 2 feet. Zip cord does not cost that much. It just doesn't. That's $4, but I don't know how long it is. I've seen cheap extension cords. We're running 1 watt. We don't need much wire. Even if you put 12 of these together, you're only pushing freaking 12 watts through the whole thing. So at this point, you might actually be better off buying like a 50-foot extension cord and just chopping it up. How about we just search for extension cord? See what comes up. Maybe the 15-foot is the problem. There's a cheap one, but how long is it? 3 meters. That's not horrible. And they do have a US plug? No, that's not a US plug. That's a UK plug. But that's 5 meters. That's what we need. That's the price we need, $1.62. We just need a US plug. Power extension cable. There we go. That's EU plug. Let's change to US plug. I've seen it. That exact cord. I've seen it where you have the option of picking EU or US. I think it's showing me USB. No, that's not an extension cord. That's a figure 8 cord. This is annoying. I got an idea. I saw it under choice, under Dollar Express. Although I think you can't search on the PC. There it is, right there. You can't pick the other options. That's what I need right there. 5-meter US plug, 5 pieces, $8. So for $16, you have 10. That's exactly what I need right there. But I can't pick it. But can I go to your store? Unusual traffic from your network? Bullshit. That's useless. I bet. Okay, can I do this? There it is. $8.57. Perfect. Is there different ones here? What's these different ones? What is all this? EU, 3-meter. Oh, they even have switchable ones. But you don't want that for outdoors. What you want is this. What's the difference here? US plug, EU plug. So there it is. 5 meters. That's over 15 feet. More than enough. So you would cut this end off here, long enough to go to the top of your fixture and out the bottom. And this way you could just daisy chain them together. And those would just connect to these here. Now I wonder, can I get these light bulb sockets for cheaper here? Add to my picks. Out of stock. It's out of stock. That's why I can't get it. Oh, we're still in dollar. No, it's Dollar Express. I did a search. This one is the one that's available. Add to cart. This never works. See, failed to add. I can't add to cart on the PC for some reason. I don't know why. What I can do is share this. Right here. Really? Screw you. You gotta be an asshole. Do they have a little note program? See, right now, maybe you guys can help me with this. Right now, this is what I do. I go to, you're still loading? Stop loading. So right now, what I do is I do this. Extension cords. And I send myself a link. And of course, even if it doesn't send properly, it's in my outbox right there. Now I can bring this up on the phone. What I would love is a little note app where I have like a little icon down here. I click and I have a little like post-it note that pops up. And I just put whatever I want in that post-it note and then close it. And then when I go to my phone, I have a similar post-it note app. I just tap it and I can see all my little post-it notes and share that between any devices that I'm logged into. Does Google have something for that? Is there anything that exists that does that? Because it'd be especially nice if I could just do something like this. You know, right click. See how this? I have different options here. It'd be nice if I had an option to add to sticky, and it would just become a sticky. And then I can load that program on any other PC or my phone and access those stickies. That would be really, really nice if I could do that. For any right-click context menu, whether it be a web address or whether it just be a chunk of text. It'd be really nice if we could do that. Hey, Asger. We're going to try to see if we can make these. Now, the question is, can we 3D print these? The answer is yes. The second question is, can we 3D print these for less than Home Depot sells it for, $25? The answer is probably no. However, we can make the equivalent of what Home Depot makes, maybe for less than $25. So what we need to search for, I saw it. Let's duplicate what Home Depot made first, and then worry about converting it to 110 volt. So LED timer. I've seen these available dirt cheap. string. Okay. I've seen them. I know they're available. And they're stupid cheap too. It runs on 3 AA batteries, and it's a 6/18. You know, it's on 16, off. Lights. There it is. Right there, right there. Battery operated fairy lights. I just need with timer function. That's what you need right there. So there's your warm white. There's your timers. 2 meters tall, so you'd wrap it 3 times. And what we do is we hang it from the tip of the bulb inside and let it dangle down. And then you'd have your little battery pack. Now, the thing is, it's not automatic. You have to turn it on at the right time. So you wait until it gets dark outside, and then you turn it on. And after that, it'll run for 6 hours, turn off, and then it'll wait 18 hours, and then turn on again. So it'll run a 24-hour cycle. So $2.34 for each one. And if you're going to make 10 of these lights, you buy 10 of these. So this is the way to duplicate what Home Depot does. So this 2-meter light string inside, our bulb is going to be about probably 3/4 of a meter tall. So you would just keep looping this around itself to create yourself a little strand. You'd hang that from the inside of the light, and then would just hook onto the bottom, probably like with a rubber band, to keep it straight in the middle. And that would be like your LED filament, your filament bulb inside. And yeah, so $2.34 for each one. Yeah, we could do this for less than $25. Okay, so that's it. That's all we need. All of this is only needed if you want to do 110 volts. But if you just want to copy what Home Depot has, you can do this. And if you want longer runtime, use multiple battery packs. Don't go to D cells. D cells are too expensive. It's just silly how expensive they are. I would even say go rechargeable batteries, but then you'd have to go out and change them every now and then. So if you really wanted to have a long run time, of course I have no way of copying this easily. This is really annoying. There's no way to easily transfer this. I'm going to have to look that up later. There has to be an easier way to do that. Okay, so for now, where's my duplicate tab? There it is. Three times AA. Okay, so here we go. This is what you need. You need this one. So you need this one here. And what you do is you buy 3 of these. And you link them in parallel. So you put 3 of these inside your light. And you wire them up in parallel. Or if you're a little creative, you only have to buy 2. And you can use the 3 that's inside the device. And you can make like a JST plug to connect these together. And so now you're running 3 sets of AA's in parallel. That will give you the runtime you need to get through the whole winter without having to change batteries. Also, these are the bulbs that I would use in this light if I'm going to run 110 volts. These are 1 watt frosted. Here's a 6-pack for $6 or a 15-pack for $16. These are perfect. They're little T3DP 27 tubular bulbs, little 1 watt bulbs. You can even dim them to cool them down if you want to run less power. But yeah, this is what I would run. These bulbs. All right, let's make the light. Now that we know we can do it for $2 and change, let's make the light itself. Okay. Close, 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 close. Open Tinkercad. Oh, really? Share. Not exactly what I want, but this could work. Oh, This probably needs to be enabled. Let's see. How do I make these longer so I can fucking read them? There should be a device sharing option. Sound, NFC, extra dim, mic, hotspot, wallet, screencast, color inversion, sound streaming, device. What's this? Device controls. Quick share. I bet you quick share is it. Visible to nearby devices. I agree. Everyone. All the time. Continue. Everyone. Okay. This might be exactly what I want. Who said that? Woozius. Thank you, buddy. You can use Google Keep on PC? Okay. Let's see. Look for nearby devices. I have this set up to share now. And I do have device sharing on. Why isn't this seeing it? We are connected to the same network, right? I don't think I need to be, but yes, we're connected to the same Wi-Fi node. Why isn't this working? Because this would be perfect. If I could make this just snap right into my phone, that would be perfect. Why isn't this working? It says looking for nearby, but probably because this is a Windows thing. I don't want to do this. No, every time. Why isn't this seeing my phone? I have sharing turned on. Does it require Bluetooth? I have Bluetooth and Wi-Fi turned on. My account is there, device name, anybody nearby. No time limit. Quick share uses Bluetooth scanning. Maybe that's something I have to enable separately. Right? Yes. No, I use Gmail. I don't use Windows. So settings, search, share. USB tethering, cross device services. Oh, maybe that would be it. Oh, it's only phones though. Done. I want to do it with Windows. Yeah. This might be a Windows only thing. Quick share. And I don't have this. Devices sharing nearby share. I don't have that on my phone. on nearby devices. Yeah, I know. Told you to. This would be perfect. This is exactly what I want, but I'll figure it out later. Let's get into the thing. That's all right. I'll mess with the Google Keep. I know that. I know I've used that before. Well, I want something simpler though. I want like a little sticky, like a post-it note equivalent. I mean, why? This should be simple. I mean, why can't we do what fucking the Expanse does? I walk up to a screen and I just go like that, and it appears there. Why can't we do that? Okay, how hard can it be? It can't be that hard. I mean, well, I know it's not as simple as that, but still. Let's see. I did find a basic shape we can use. Oh, that's taking a long time, which means that might be a complex shape. How complex is it? It's not that big. Let's see if I can shrink it a little bit. The Martian? No, they didn't have that. Well, maybe on the Ion ship. I didn't check that. Oh, I don't. Just go away. Let's see. Auto repaired 4 errors. We do want to take care of that. Simplify model. Let's go to high. Apply. Let's export it. Let's do fix with Windows Repair. Then export. Yes. Go away. And we are down to 547 kilobytes. Much better. And this is still trying. You just keep trying there, buddy. In fact, let me rename this. Otherwise, I won't know which is which. I'm gonna know which is which. I gotta reset this. Yeah, the Mars. That was a great movie. I don't care how dumb some parts were. I don't care. It was a great movie. McDonald's breakfast this morning. My neighbor rang me up and said, "Hey, you want to go to McDonald's? I'll treat you." I was like, "Sure." So we got some McDonald's. Okay, first, let's just straight up make this 400 millimeters tall. Okay, how big is that? That's 212 by 212, which means we can print this on pretty much any printer, actually, just by splitting it in half. Nice. So let's actually change this to 200. Excuse me. Wrong way. I hit the wrong button. That was my fault. You hold down the shift key, then you type in 200, and it will adjust all 3 dimensions. Now, the reason we're doing that is so that you can print this on a regular printer. Because that's tall. We are now 376 millimeters tall. I do not want this to be hollow. There's not going to be an easy way to fill that in, is there? Well, filling in the bottom will be pretty easy. Nope, this way. Don't be a nudge. This does not need to be that refined. Let's see here. Let's make this transparent. Okay. I need you. Now I need you. Oh, come on. Stop being a nudge. Center, center. Now what we do is we grab this. We hold the shift key, select this, and make it bigger. Until you're about as big as the thing is. Right? There. Okay. That makes us 109 millimeters. Okay. So our base is 109 millimeters, and now we are all nice and solid. Now we take a sphere, increase the steps, and we make the sphere. Let's make it bigger. We'll figure it out later. Let's see. Center, center. Okay. This and stretch. Here we need to make it bigger, so I'm going to hold shift now. There we go. Let's do this. Let's do a regular, let's do this kind of stretch. Like that. Then do this kind of stretch. Like that. Now, come on. Full screen. That's a little bit better. Now we want to drag this up like that. Make this bigger. We want to do this. What I'm trying to do here is fill in bulb. Okay. Control D. We just lift this bad boy up like this. Now we start creating a second one. Does this. I think I can do it from here. We bring this down a little more. Bring this up. Bring it down a little more. Bring it up. I'm trying to distort this. Let's do this. Oh, there we go. Now we're getting somewhere. Shorten it again. There we go. Now we control D again. We bring this one pointier. Nice. And then more. Control D again. We do that. There. That should fill in all of the empty space. And I like that shallower angle, but I do want to get rid of that. Should be able to do that by doing this. Yes. Nice. That is fully filled in, I believe. Merge. And now we are transparent. We look for holes. And I see no holes. I see a couple of lesions on the skin, but nothing I can do about it. Okay, we have a giant C9 bulb. Now, to print this on a regular printer, you would just print this in 2 pieces and glue them together. And we would print this in phase mode. So there's our bulb. I tried that. I never got it to work. Every time I try to do that, it fucks the model up. Like, bad. I'll have to play with it again. It's been a couple of years. But I tried that. I thought, oh yeah, I'll use my printer. And it just clicks on it. Yeah. It was so bad, it was horrible. It just mangled the model for some reason. Unless I just brought in a bad model. That's possible too. What we do is we export this. Super Jerry Lilu. Lilu multipass. And then we delete this. And then we re-import it. This way it gets rid of all the editing so that we have a simplified shape. Otherwise, you run into problems. All we have to do is remember that we are 109 millimeters at the base. There. Perfect. Totally happy with that. How does that look in the slicer? Super jar of Lilo. Please go away. One shell, no errors. Yeah. Perfect. No issues. We are on desktop. Let's go back to desktop. Now we need to do something different. For now, I can actually just delete this since we have it saved. I need to make this a window. Like this. Because we need to always use AirPin view. We need to duplicate this, the space here. That over here. I did not ask you to do that. There's a way to turn that off. How do you turn that off? That's pissing me off. Turn off full screen when you touch the edge of the screen.
Here's what I found on the web.
Not what I want. There it is. I hate that so much. Snap on or off, yes. Click to open Ease of Access Center. Where the fuck do you click? Probably in here.
Always scan this section.
Please scan this section.
Under Make It Easy to Manage Windows.
Start magnifier.
Start magnifier.
Shut up.
Start narrator.
Start narrator.
What are you doing?
Start on screen. Always scan this section.
Start on screen. Always scan this section.
Idiot. Select Prevent Windows from being automatically arranged when moved to the edge of screen checkbox under Make it easier to manage windows. There is no make. This is what I hate so much. Why the fuck do they have instructions that don't exist? There is no make it easier to manage windows. It's like, what the hell? It's not there. Windows plus left arrow on keyboard? Windows left arrow? That just did it! I don't want to do that. That's pretty cool, though. How about it? Oh, for Christ's sake. How about make the computer easier to use? Nope. So what the instructions from Microsoft tell me to use doesn't exist. What are you doing? Why the fuck can't I scroll anymore? Under Make it easier to manage Windows. Oh, wait a minute. Here we go. Explore, click, make the mouse easier to use. Make the mouse easier to use. I was in the wrong section. Prevent windows from being automatically arranged when moved to the edge of the screen. There we go. User error. I fucked up and didn't read the instructions. There was one step before it. So, time for an adjustment. Okay. Yeah, I feel better now. Ah, yes, no more snap. Oh, thank God. That's so annoying. Oh, okay, so let's create a base. We know it needs to be 110 by 110. It's close enough. So this needs to be the opening. That's our light. So it looks to me like we're going to use 2 cones and a cylinder. Let's just make the cylinder then. 109 is the light. So let's do 120. This still needs to be close, approximate. Now that base socket looks like it's approximately 2/3 the height of the bulb. Yeah, it looks like about 2/3 the height of the bulb. So let's make it 300 for now. We'll bring the bulb in later and see if it looks right. Because that does not look right. That looks too tall. Let's go 200. That looks better. And then we're going to drop a cone on here. And we're going to drop a cone down here. This cone is going to have maximum sides. Let's make it 60. Yeah, 60 looks about right. We'll adjust it later. The top radius is going to be 60. Nope, it's bigger. 65. And the bottom radius is going to be, let's make it 80. This is 60 tall. So we're going to take both of these and raise them up by 60. Okay. This one is 65. So this one's bottom radius is going to be 65. Base radius 65. And the top radius will be 80. Okay. And let's make that about half the height of the other one, so 30. Let's align. Now, if I didn't know better, I still think that looks too tall. So I'm going to shorten this to 150. Lower this down to 50. 50. Okay, that looks roughly approximately right. Is there no way for me to round the edges of this? I'm going to print it as a separate piece, so it's not that important, but there's no rounding option. There's nothing like, you know, where I can make the box curvy. I thought I could do that with the cones. I guess not. Okay. I think this is too tall. Let's make this 50. Into this. Let's bring in the bulb and see what it looks like. These, we're going to make this green. Because we're all going to scale everything to the bulb. It's going to make it too tall, but that's okay. I mean, that's definitely too big that way. How tall is this? 585. 585 divided by 25.4. This is only 2 feet tall. I'd like it to be bigger. I want it bigger. I'll scale everything down for the people who don't have big enough printers. Okay, so how do we do this? Think. How do I do this? I guess I'm going to have to make it 2 pieces. There's just no way around that. It's got to be 2 pieces. I was hoping to print the bulb in 1 shot, but that ain't going to work. Because 400 millimeters is only 16 inches. So even if I made both parts 400 millimeters tall, that's only 32 inches. Well, there's a couple of things I can do. I can print the base ring as a separate part. Let's do that first. By printing that with just a tiny little lip, I can still have alignment. Oh, I just broke it. Yep. Oh, I broke it bad. See, this is what Stickeryeti sometimes does. See how it's just that edge. It said no. So I have to see how this is dark. That means we're outside of the work area. I have to bring it down in the work area, join it, and now I can bring it back up later. Okay. So what happens if I make this 290? Okay, that makes this 493. Okay. Let's align everything. Align. Align. Okay, now we need to scale up the base. Yes. Let's just select everything, unselect this, and let's scale you up a bit. And then we got to raise you up again. That's not fat enough. That needs to be fatter. Yeah. Let's see here. Let's make this 200. Let's do another alignment. Why does that not look right? Probably is right. I'm probably just seeing it wrong. Yeah, it's aligned. Did I screw the dimensions up? No, 200. Oh, I did. Oh, I thought I hit the shift key when I did that. No, I gotta do this. That's why. And align. That looks better. Okay. Yeah, that looks pretty good. Okay. Why does that look off? Like the shape's not right. Okay. But is it just me or does this look too tall? That looks a little bit better. How tall is the whole mess now? 721. 721 divided by 5.4. That's only 28 inches. I still need to make the whole thing bigger. Well, we could start off by making this taller again. 495, and then we could scale the whole thing up. Nope. We're reaching our limit. I can go to 297. That's about as close as I dare want to get to the edge. Why does it do this? Just do as you're told. Don't argue. That gets us to 772. 772 divided by 25.4. That gets us to a little over 30 inches. So the question is, should I work more to make this taller, or is that good enough? I could make the bulb taller since we're going to have to print it in 2 pieces. So I could add more to the bulb. I could just go to that. Go 555. As long as we don't go over 800 millimeters, we're fine. 820. 820 divided by 25.4. That gets us to 32. Now, if I raise this, let's raise it 60. And then let's make this 60 taller. Yeah, that's fine. We can do that. Make this. No. Just make the whole thing 320. The proportions look good. $330. There we go. Now we're inserted. Good work. That gets us to 880. I closed my calculator for some reason. 880 divided by 25.4. That gets us to 35 inches. Let's go up another 60. 50. I think I'm going to make this fatter too. 390. I think that needs to be a bit fatter now. Looks too skinny. Let's go to 225. And then shrink it back down to, what did I do? This is 390. We'll do that and then do this. Okay. Yeah, that's looking better. The proportions look better. Yeah, I like those proportions better. Though, I think these are too big. Let's shrink the base radius a little bit. Let's make it 73. This top radius is going to be 73. It's not really 73 anymore because we messed up some of these dimensions, but that's okay. Although, that looks like it has a wider top than a bottom. Let's make the top radius 76. And now let's fatten it up a little more. 225 by 225. Line everything. Okay. That doesn't look too bad. Ow. How do I make that clip and make it look nice? C9 clip. SVG. Possible it's a C7. The Corvette. All I need's a drawing of it. C9 clip art. All I need is one drawing of it. And then I can extract that into a 3D model. But I don't have an easy way of making that shape. That shape would be really hard to make. Someone has to have a drawing. It's got to exist. Someone has a drawing of it. Why not include oh, maybe. I try to keep it simple, but you're right. That is technically part of the socket, not the bulb, isn't it? Socket. Thank you, Big Bag Joe. You're right. It probably is part of the socket. The thing is, not all of them have that, though. Like, see, all these don't have the clips. I need that right there, that clip right there. I could make one, but it's not going to look nice. If I could just find a drawing. See that? I need that shape right there. I need either a picture that's side on, meaning not isometric like this. I need a side on shot of it. Because then I could just trace it out. Ooh, that's pretty close. That might be close enough. That might be close enough. Oh, there it is, right there. There, nope, not quite. But I bet you that's close enough. Let's spend a couple more seconds looking because we might find something better, but that looks pretty close. See, that's exactly what I need, but this nicer curvy one. That would be perfect, a line drawing. But I think we can make what we found work. That's close enough. Let's make it work. This and this. Did it go somewhere else? Oh yeah, it went in documents for some reason. Let's see. Let's just do a trace. Go view. On screen. Actually, we can crop it down because we don't need this much. did you do? See, it does that. I hate that so much. I don't know why it does that. It's a bug in Photoshop that does what you just saw right there. See, it refreshed the screen, which undid what I was doing. I don't know why it does that. It's really freaking annoying, though. I can tell you that. Ah, beat you, asshole. I just undid it. It said, screw you. Dick. And I don't know why it does that. It's a weird, it's a little bug in Photoshop where it just refreshes. Oh, come on. New Control P. Save as. Can I save it as an SVG right from here? No, I cannot. So JPEG it is. We're gonna call this. Oh, I know. We're gonna call it Clippy. Just because I can. Okay. Clippy it is. Let's see here. Convertio. The JPG to SVG. Convertio is very handy. Wish there was an offline version of this. Clippy. Convert. $4,864 miles. Really? That's it? No way. That's too short. Oh, it's only 4,700 miles. But it seems too short. Oh no, okay, that's 3,000 miles. Okay, because this is about 1,800, 1,900 miles. So that would make that 3,000 miles. Okay, yeah, that works. That works. It seemed too short. I thought the Atlantic Ocean was bigger than that. Wow. Uh, Download. Hi, Clippy. Import. Clippy. Hi. There's Clippy. Okay, now we need to rotate that this way. I think that's about it right there. We make it thicker. Okay. Now we do this. Then we do this. Then we do this. 0. Ooh, we almost got the scaling right. Nice. Look at that. Let's do that. Almost exactly right, too. Now, I'm probably going to actually want this to touch that, so it'll print better. It'll be stronger. There's no real reason to make it separate. I'm actually going to intentionally embed that, just because it'll make the whole thing stronger. Okay, now we have one last thing we got to do. We have to do our imprint on the sides here. So let's take all this and make it a lighter color green. So this is easier to do. That definitely needs to be bigger. This. That's not what I wanted you to do. That's what I wanted you to do. Why do you keep doing that? You little stinker. Okay. That looks about right. So now we need to bring this back out here. We need to rotate this back down again. Bring this back down to 0. 0. Okay. Now, how big is this? We're going to make it 50. Okay. Then we are going to drop one of these here. And we're going to make it 50. Holding the shift key so it does all 3. We're going to drop another one on here. And again, shift key, make it 50. Okay. Should be able to do this. This and do this. There we go. Then we do this. There we go. Oh, I didn't change the sides, did I? No, I didn't. Do I have to? Yes, I do. That's not right. Okay, undo. Number of, why can't I change the sides? Oh, I have to change the sides of this. That's right. I can't. I didn't realize I couldn't do that. Okay, so we have to use a cylinder. Why would you do that? Don't be mean. You. Anchor on you. Yes, yes, yes. There we go. Oh, I guess that's the right one. Now, what we do is we change the number of segments, sides, until it is equal to the hemisphere. There. That is 36 sides. Otherwise, they will not merge correctly. Okay, this is going to have to move. Let's do this. Let's put a work plane here. And then let's move this down to 0. properly connect them. Okay. Now we take this and we join it. Now, see, there's no lines. And if you make it hollow, there's no cracks. See how it's all just monotonous or monogamous or homogeneous. Okay, that's what you want. If you don't make the sides the same shape or align them properly, you'll see little cracks, and that will cause you problems. Okay. Now we take our pill, we rotate it. And now we can scale this. We can do whatever we want to this. Right there. It is too tall. We shorten it. About that big. Take this and this, line, anchor, center, and center here. Now what we do is we take this, make it transparent. You can see what the overlay is going to look like. Okay. I think that's probably too much. Yeah, that's too much. What we do is we just drag it out. Hold the shift key to form on an axis. Yeah, like that. Okay, now we drop our master ring. Yeah, that looks pretty good. Drop a master ring. Maximize radius and sides. That is still too small. There we go. Oh, too big. There we go. We take this and this, align, anchor this, center, center. Now we're centered on this shaft. We take this and this, Control D. Now, that's not enough. That's too far. Okay, so we take this and this. Why are you doing this to me? Don't be a pest. It's a good way of getting bitten. I think 30 is going to be the optimal here. And Control D it all the way around. Why didn't that work? Because I'm a dummy. Let's hide one of these. Delete the rest. Bring it back. That. This. Control D. Then rotate. Dummy. Now I can duplicate it all the way around. Oop, a little too many. Okay, now one of these is going to interfere with this. So actually we need that. Don't we? Does it have that under the clip? Yes, it does. Okay, so we'll leave it. Okay. Now we hide this. We select just the center. Join it. There. It's actually a little too deep, isn't it? No, it kind of looks good. But I do think I need to make it a little less deep. Up, 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 up. Yeah, let's pull it out a little bit. It's just a little too much. Let's go out just a little more. But now we're a little shallow. We're going to make this taller. We're going to align, anchor, center. Yeah, that looks better. How much space do we have there? It goes pretty much up to the top. Let's go a little taller. Here, center. That looks good. Like this, like this. Control D, rotate 30 degrees, all the way around. Okay. Select the center, unselect this. Looks good. Now, make sure there's no gap in here. I think we have a gap. Yeah, we want to push this in. We want to get rid of that gap. I think I got it. Yeah, we are connected there. I think we're going to want this clip a little wider, or is that good enough? I mean, the proportions look okay to me. How big is the clip? Too tall. We can fix that. Ooh, is this too big? 309. Ooh, it is too big. No, actually, got to include the top. Bigger. 314. Ooh, it's too big. Yeah, we got to shrink this down. Okay. 289. So I can add more. Actually, I can just rotate this. Never mind. We're fine. Yeah, because I like it big. We can just rotate it. So we're fine there. All right, let's bring this out of here. A little more. Yeah. Now we're separate, but we're still connected. Moving through. That. Right. Because if I take this, let's get rid of the master ring. Delete. If I take this whole shebang and rotate it 45 degrees, we are too big still. Make sure I did that right. 1, 2. We are 313 by 313. So we need to make this a little bit smaller. Okay. 340. But if we rotate 45 now, we are 305 by 305. We are still too big. Shrink this a little more. That's probably a little too thick. Let's make it 50. Yeah, better. Line, center, line, rotate 45 again. 297, 297. We are good. Okay. 3 feet tall, and it fits on a 300 by 300 printer. You'll have to print this as 4 pieces, most likely. You could print this as 1 piece, but it'll probably print better as 4 pieces. So you print up to here, and then you print this upside down so that we can print a socket to install the light into. We want to do this. I think that's the best way. I could make it all threaded. but there really isn't a reason to make it threaded. The bottom will be open. So if you have to service this, you can service it through the bottom. And the bulb comes off, there's not going to be anything in the bottom. In fact, we might even have to put tabs on the bottom so that you have some way of attaching this thing to the ground. Okay, let's split it up. Let's do this, that. Now, one other thing I was thinking about is I could print this clip as a separate piece that you then glue on. The reason I would print the clip as a separate piece is that would allow us to print this base in vase mode. And printing that base in vase mode would save us a lot of plastic. First, does that light go all the way to the bottom? No, it doesn't. It does not go all the way to the bottom. I gotta fix that too. Yeah, let's make it good. I'm gonna do all this work. Let's make it good. So let's bring this up. That's gonna be more like that, isn't it? Yeah. See how it's lifted up off the bottom? The clip we could just glue on. I could put screw holes in so you can screw it together. I might actually want to do that. No, you'd have to, yeah, you can screw it together, but you'd have to drill the hole because it would break vase mode. Yeah, I think I'm going to do that. Just because I want to. That means I don't need to rotate anything. We're going to be printing the clip as a separate piece, so 5 pieces. I mean, you could print this all as one piece and just glue it together, but that would use so much freaking plastic. You're going to triple the amount of plastic you need. By printing it as separate pieces, we dramatically reduce how much plastic you need. Especially with the 1 millimeter nozzle, I can do it in single perimeter vase mode. Yes, that's what we're going to do. Yeah, I think that's the right thing to do. So that means I have to cut this. So I have to take this, join it together. Duplicate it, turn it into a hole, and join it with this. There. Now this becomes a separate piece and has the appropriate cutouts to fit directly into that. Now, there is other changes I want to make. If we're going to do it, let's do it right. Actually, the right way to do it would be to do a screw on the inside into the handle. Yeah. Huh? That's the right way to do it. Because this is all going to be open. So you just reach in there and put a little screw right from here to here. Okay, yeah. I was thinking about putting a hole in here and drilling. No, you just do it from the inside. And this way you don't even see any holes. Oh, yeah. Let's see. Let's see how we're going to do this. Just a cylinder. How big of a hole do we want? Deck screws. Or screws. Amazon. We're going to do stainless. Let's just find some cheap stainless screws. They don't have to be big. We definitely do not want beveled. We want pan. Otherwise, it's going to tear. I'm trying to drag it like I'm in Tinkercad. See, what you don't want is you don't want this. You don't want these cone-shaped screws because otherwise it's going to pull right through the plastic. You could use a washer or you just buy these. Let's see. Number 8 by 1 inch. That should be fine. That's a little expensive, but it's 250 of them. But that's got the fatter head too. But a half inch would be enough. These would work. Perfect. Right there. That's it. Right there. It's too many though. But you can get it for 12. Let's see. Are they also called truss head? Yes. Truss. Although these are going to be inside. They're not going to get rusty. I mean, they're just not going to get rusty. Like, this is fine. 3/4 inch black modified truss head screw. Even that's more than I need to spend. These are half inch. That's getting a little close. Half inch is, that's 12 millimeters. That still should be plenty, but I'd rather go longer. Just to make sure they actually bite. So 3/4 inch or 1 inch, I think would be a better deal. It's gotta be something super stupid cheap. I'm looking for like $5 because I'm a cheapo. We're getting close. 650. Ooh, here's something. 120 pieces, 3/4 inch, zinc plated, $4.99. Oh yeah, this particular one's on sale, and that is the truss head that we want. Yep. Okay. Size of hole for number 8 screws. So it looks like we want, let's assume it's hardwood. So let's, well, it is soft, but somewhere between 7 and 11/16. So 11/64 inch, 2 millimeters. So we're a 4 millimeter hole. I'm probably going to make a 5 millimeter hole since it's probably going to drape. It's going to droop a little bit, being but let's go 4.5 millimeter. I think that'll probably be enough. Oh, let's order those screws before I forget. I can use these for a lot of things around the house, so I'm not too worried about that. I don't have screws this size. Ooh, these are 1 inch, but they're the cone heads. Is this more of them? These are stainless? Oh, it's only 25. I mean, that's enough, but I'd rather get the 100. Although 10 for 150. I could use stainless screws around the house. Is it 3/4 cheaper? No, it's exactly the same price. Ah. Self-drilling, self-tapping. I'm just gonna go with the cheap ones. $5. Get rid of all this. Save for later. Save for later. Save for later. Save for later. I don't think I need any of these, but save for later, save for later. It'll be here this Friday. What the hell? I told you not to do that. Why would you do that? $760. Lace order. Can I get some of these fairy timer lights off Amazon? As a temporary, just to try it out. You don't want these. These will work, but these are coin cell. You don't want that. That's the best deal because you get 5 of them, but I don't want 5. I don't spend that kind of money. Here's a 2-pack for 10. Here's a 2-pack in warm. One pack for $5.99. Oh, I just don't want to spend a lot of money because I really don't have much money. Definitely don't want that because it looks like AAA batteries. And this is the right deal here. $17.99, you get 12 of them. That's actually cheaper than what I get on AliExpress. Seriously? 18 divided by 12. Yeah, that's cheaper than fucking AliExpress. You gotta be kidding me. Wow. That's incredible. I mean, that's genuinely incredible. Are these timer based? Because these are more durable. And they're bigger emitters, too. Okay, so this does have timer. And you can also make this do different things too. Let's verify this actually has timer. Well, I certainly don't need 33 feet. LEDs. That'll certainly make it bright enough. Jesus. Does it actually have 6 to 18 timer mode? It says timers. How long will it run? 6 on, 18 off. I can also dim it, because that's probably going to be too bright. If I dim it, I can increase the runtime. It's 100 LEDs. That's a lot of LEDs, but now RGB would be interesting, because then you could do them all in white and then change the color. But then they don't look good during the day. I think I'm going to go with this one, because this one just has a lot of other things I can use with it. I don't mind paying a little more, because it's going to be 33 feet, 100 LEDs. A much, much sturdier, it's more robust. UV light will destroy these wires. I've already had some get destroyed, but this is going to be inside an enclosure. So I'm really not worried about that. My eyes are getting better. Last 3 days, my eyes have been horrible. Okay. I think we're good. I think this is going to be good. Add that to cart. Oh, can it be delivered in time? Yes. Okay. We have the screws and we have the lights. So I can do one. I can't do any more than one. I think I need more money. This would work if it's timers. This one might not be timer based. This might be straight on off. Is this one timer based? Yes, it does have a timer. All right, so if you're going to build a bunch of these, this is what you want to probably do. Just because you get them for $1.50 a piece. I'm going to add that just in case. If I get more money, I can do more. But I'll just leave it in the cart for now. I don't lose it. But these are not those. So the other screws we're going to use. Okay. What is this thing doing? Is it this way? This way? I don't know. It's amazing how little power this tablet uses working as a second screen. It's like during my entire stream, it uses almost nothing. Let's see here. That's it. That's all we need. Okay. Now let's do this. Sides. We're going to make it 4.5 by 4.5. Make it nice and long. Then make it long. Hey. Now we're actually going to want to keep it even, not with the shape of the unit, but with the shape of the base here. so that the screw head doesn't get all wonky. So think like that. This, and then do this. Come on, play nice, or I will bite you. Yes. Doesn't actually have to be sticking out. Do this. Good. Control D, bring you over here. Okay. That looks good. Here's what we're gonna do. We're gonna hide this. We're gonna join these two together. And then we're gonna center them on this. Like that. Turn these into a hole. Oh, we gotta bring them up too. We need to Control D. Put them up here. Okay. Now we gotta rotate these back to almost level. That. Come on. Work with me. Bring them down into the center of this. Like that. You can use one if you want, but I would advise using two. Oh. Okay. Not quite level yet. Close enough. Hide you. No, I don't have to. I can just get rid of you. Okay. Those two will go into that one. Those two will go into that one. Hole. Bring it back. Now, what I really need to do is to put a dimple where these holes are. Let me explain why. First, please stop messing with me. I actually figured out why it's doing that, by the way. So, we're going to join these together. We're going to Control D, and we're going to hide one. Not what I wanted to do. Oh, I can't do that easily. Yes, I can. Hide this. We take one set of these and this, join it together. Which gives us this. Now we bring it all back. Turn you back into a regular. And you can see now we have two holes in here. 4 holes for the screws. But now here's the problem. We need some way of telling where to screw these holes in. There's two ways I could do that. I can make a template, and you could print out the template. Do it that way. Or we can do it a different way and not only make it markable where you have to put the holes, but make it very easy for you to do so. And we do that by putting a hole in this model, but not a hole, a dimple. We have to put a dimple in this model. We take this, we split it. We take these, we split them. Take these, we split them. Now here's what we do. We put a ball on them. Drop a ball right there. And we make that ball 4.5. 4.5 is enough. Just keep it simple. Control D, since these are aligned with each other. Nope, that won't work. That won't work. Let's do it the right way. Right there. And of course I can't friggin' see it. Grab you, 5. What we have to do is center these. We put a work plane here. We take this piece and this piece. We did not work. This piece and this piece. We center. We anchor this on here, and on here. Oh, we don't have to do that. It's fine. But we'll do that anyway. Okay. Same thing here. This. Nope. Let's just to make sure. Put a work plane. This. Align. Anchor. This. And with this. Now, take this and this, and we delete them. We take this and this, we join it. We still have that work plane, that's important. Join them, turn them into a hole, and we move them until they bump into the model. We create a little dimple just like that. And now that dimple will not only be printed in the vase mode successfully, but now you will know where to put the screws, and the dimple will keep your drill bit aligned or your hot knife aligned to put the holes in exactly the right spot. Yeah. Align. Drop one of these here. Drop one of these here. Okay. Shrink this to 5 millimeters. Shrink this one to 5 millimeters. Bring it in closer. Stop being a nudge. Select this and this. Align. Anchor. Center. Top. Select. Shift. Select. Align. Anchor. Center. Top. All right. Delete you. Ball. Join. Transparent. Our work plane is still correct. Move in until we create our dimples. And that's it. Now we just join those. Bingo, bango, who's your daddy? It's all good. There. Now we have these dimples that won't break phase mode, but it will not only tell you where to drill the holes, but it'll guide your drill bit to drill those holes. Just use like a 7 millimeter drill bit. Bring this back. There it is. Now this will print the holes so you won't tear the plastic apart, and it'll all self-align. You just screw it together. And this handle will come in really handy too. Because you'll be able to reach it in there and go, ee, ee, ee. Okay. That's good. Oscar the Grouch's house? Okay. Now comes the tricky part. We have to make a bayonet mount for the lights. Okay. Let's put the work plane back where it belongs. So this piece is now done. This piece is now done. This just prints in vase mode. This just prints in regular perimeter mode. 2 perimeters will be more than enough for that. This has the dimples for guiding your drill bit and placement of the drill bit. This has the holes. Those holes in the right spot? Yes. The holes to screw that in. Now, the whole you could print this together, but then you can't use vase mode. And by using vase mode, this will weigh 1/3 of what it would weigh otherwise. Let's put them back. Let's change the color of this because we know it's different. Let's make this something not so stupidly bright. Let's just use white for now, I guess. Okay. This is pretty simple, so I can separate this. I'm also going to do this because we're actually going to need the space. Because now that we're putting it in 2 pieces, it doesn't matter how tall it is. It's 613, so that's fine. Now, you don't need to include provisions for draining because it's all hollow. When you print this, this will have no bottom layer. Or if you want to make it a little stronger, print a bottom layer with just infill. No top and bottom. Just make the first like inch just infill. If you want it to be a little stronger, but I don't think you need to. But no, this will be hollow, open. So any water that gets inside will simply fall out the bottom. So there won't be any bottom here, and there won't be any top here. Voice ink is off. I can fix that. Okay. How's the voice ink now? I sing from nice. You just gotta let me know when that happens because I have no way of telling on my end when it's doing that. Okay. Next stage is to make this part. This part will not be vase mode printed, at least not entirely. And actually, it won't be vase mode printed at all because it has to have the socket for the bulb, and it has to be able to interface with both of these parts. And I don't think there's any easy way for me to vase mode print that. Check. It actually might be possible to vase mode print. Oh, that might actually work. That might actually work. No, it's gonna glue them together. Screw it. There's no, although it would be nice to screw them together with screws. Put 3 screws into this to hold them together. I'm using OBS. Let me check on that real quick. OBS audio drifts out of sync.
These came back from a search.
PC. I'm using a PC. Core i5, 16 gigabytes. OBS settings. Audio general. There's no audio there. Oh, audio. General. 48 kilohertz. Audio buffering. Why can't I scroll? I don't see buffering. Oh, no, that's different. Okay. That's fine. Now, right-click audio, select advanced audio properties. No, I don't want to do sync offset because I do not have an audio sync issue. An audio sync issue is a fixed issue. My audio is gradually shifting out of sync, which means I'll just be changing the offset of the gradual shift. 3 feet tall. The idea is to duplicate the Home Depot 3-foot tall lights. Let's check out the camera. Properties. Configure video. The options to mess with that. I don't know. I'll have to keep playing with it. All right, now comes the tricky part. First of all, this is 48 millimeters tall. Let's put a box on here. Hmm. 48 millimeters tall, which brings us to about here, which means I can chop off the rest of this. Come on. Not what I wanted. Just have to make you bigger. It wants to be a nudge. let's go. That's 48. We want to go up a little more. So we're slightly recessed. That's what we want. There we go. Now we can delete you. Merge you. Oh shit, I forgot about that. Is it gonna let me do this? Ooh, this is gonna be tricky. I have to get this whole thing inside the work plane. Yeah, good. Okay. Now we have to do some tricky work. Work plane here, box here, and now work plane here. There we go. So what we need to do is to put a ball, probably the easiest way. Okay. How do we want to do this? Let's just eyeball it for now. Let's do a 35 millimeter ball. About like that. About like that. Let's see. Line this way. I think that's okay. I think we want to go in a little bit more. Why? Okay. Let's align again. No. We are aligned. Okay. We need a master ring. Sides. Get you aligned. Anchor. Bigger? Yes, it is. Control D. 4 of them, 90 degrees apart. Now, what I think I need to do is I think I need to take this and duplicate it, join it, and create myself a little tool. Really? That's how you're gonna play this game, dick. Now what are you gonna do? Are you gonna select everything? Yes, you're gonna select everything. Why do you gotta be a dick? Wanker. You know, was that out of bounds? That wasn't out of bounds. Object exceeds size limit. No, it doesn't. Am I in the wrong spot? I don't think so. I don't know why it's saying object exceeds size limit. It doesn't. Unless it's just getting pissy about something. Did it fucking the model up anywhere? Oh, no, that's a shadow. We're fine there. That's a micro glitch. We're fine there. Okay, this should all be fine. Okay, Control D. Yeah, yeah, yeah. Come on, stop being a dick. Okay. Now we take this. Make this huge. Then we raise this up to about here. Should do it. Take this and this. Join. Yeah, yeah, yeah. Shut up. Okay. Now we export this. Otherwise, we're going to make this really complex. Then we import what we just exported. Where'd it go? Really? You stuck it down there. Okay. Now, what we need to do is put this in here. Line this way. I hate when it does that. Just makes me want to rage. I just want to bite someone so bad. Now what we need to do is we need to scale this up just a smidge. Is that enough? I think it is enough. Let's make sure we're still aligned. We are. This turns into a hollow, and this gets joined. Not quite right. I forgot what I have to do. I got to rotate it a tiny bit. I might be able to do that with a torus. Nope, I can't do that. I have to do that here if I want to have any kind of control. There's another way I can do it, but I want to try it this way first. Well, that should be aligned. Am I off alignment again? No, we're aligned. Why is that sticking out? Oh, oh, I gotta just touch the center. That's right. There we go. Bring the radius up to a little 83. That's pretty good, actually. Make the radius just a hair bigger. 45. 85.5. 86. 6. No. I want to be just touching. 3. Yeah, we're too far. I want to be just touching. Let's make the tube bigger. Okay, let's go 17.5. $79. Okay, 18. $8.5. Okay, shift down. Let's increase our granularity. What I'm doing is I'm making a bayonet mount. 18. And in a bayonet mount, I need to create a channel for this to ride in. Ooh, weird, dead center. That's pretty good. This seems to be a little bigger. 19.5 and 79. Okay. Come on. Where is it? We are too big. Just a hair. So let's go 78.8. Yeah. I'm good. Okay. Let's join it. Nice. Okay, that's what we need for that. Now, I need this. How big are those balls? It is 35. Which means I need this to be 35. 35. Let's hide this for now. Now we need to do this one. This one should be a little easier. Oh, I got to be real careful with this. I cannot move this green ring. What is that? Whoa, what are you doing? The line, center. Okay. Huh? Bring this up to the center like that. Now we do this. Bring this in until we touch, just like that. And we go a little bit more. No, the sun's not right. That should do it right there. Okay. Let's Control D this. Also hide it. We take this and this. Control D and rotate 90. Control D and D. Let me select all these. Delete them. Bring everything back. There. How do you do it? Oh no, it's the wrong size. That's why it didn't work right. I scaled it up a little bit. Oh, I forgot about that. That's why it wasn't lining up properly. That's right. How much bigger do I need to make it? There. Yep, almost perfect. Almost. Let's move it out, in right there, a little bit taller. That's why it wasn't lining up. Derp. 9. Oh, I gotta do this and this. Come on. This. 50. Probably just a hair too tall, actually. Yep. Almost perfect. I'm gonna call that good enough, I think. Guess we can do it a little bit more. Yeah, that's. I think it's good enough. That's below the resolution of the printer. Now we Control D this again, hide it, select this and this, Control D that, 90-degree rotation, Control D and D, and we delete all these and restore everything. Okay, let's create our bayonet. Take this, get rid of this, and join. Very nice. So now the light bulb will stick into here and then you can rotate it. Now, what we should do is add a couple of dimples on this inside wall as a lock for the bulbs. I don't have to, but I'm going to because it's easy enough to do. I might as well. It's not that hard to do. A master ring is going to make this easier. Go a little bit bigger, just so we know we're nowhere near the problems. Center. How did I do that? I did a lock and I didn't realize it. Is it properly centered? Yes, it is. Now, what we do is we take a ball. Actually, a cylinder will work, a half cylinder. take one of these and this, and we make it taller but smaller. Do this. Okay. Then we move it in here like this. This. Okay. That's too big. That looks like it'll probably be enough. If it's too small, it'll just slide right past it. If it's too big, it's going to be really hard to turn. But this is vase mode, so we have some flexibility. Now what I do is I take these 3 pieces here and I align them this way. Like that. I make sure these 2 are still aligned. Yes and yes. And now I take this and I rotate it. I take this and I rotate. So I guess right about here. And now we Control D this and we rotate it again. So there is our lock point for the ball. Take those 2, join them, Control D, select this, rotate 90 degrees, Control D, and there. Now we have our 4 lock points for our little thingies to grab onto. But you can see the problem I've already created right there. Can you see the problem yet? Yep, that's a problem. We hide this. We take this, 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 and this, join them into one piece. Let's, oh shit, there it goes. It wasn't highlighted properly. I thought I deleted it accidentally. Now we just grab this. I can just lift it. And we lift it until it disappears. There, now it's inside. And nothing is popping out where it shouldn't. That all looks good. If you really wanted to make this nice, you'd bring these close enough together that would actually lock the thing tick into place. The bulb itself is about 600 millimeters tall. The whole thing's going to be about 3 feet tall. Delete you. Join you. And there you have it. That is our light bulb socket. This will have to be printed with a little bit of infill because it's going to need top and bottom layers. Because you don't want to see infill here. And you need this to have something to glue onto. But we might be able to do something a little different. We know that this was 110, wasn't it? Let's just duplicate it. Yeah. Take this. This. There we go. Delete all this crap. Delete this crap. How big is this? 177.63. So 180. No, we don't need that much tolerance. 177.63, 178, 179. 179 is good enough. Okay. Select U and U 179. Increase the number of sides. Decrease the height. Turn you into a hollow. Bring you into here. We're off the screen. See how much room do we have. Too tall. That's not enough. I figure we need at least 5 millimeters. So how do we fix this? Couple options. What can I do? I can make the whole thing taller. If I make the whole thing taller, that would work. Okay. Let's do that. This is a simple cylinder. I can just toss it out here for now. Okay. How do we do this without screwing it up? I actually no longer need the dimples because I've recreated them with this. So I can take all these and this and join it together. Okay. Now we take this and, oh, we can't do that yet. But I can do that, can't I? I could take the whole thing. I could lift it, let's say, I was going to lift it 8. Okay. Then we extend this 8. It's breaking it. Oh, it's breaking it. I know how to fix it. Control D. Okay. Oh, this is a fixed shape now. It's a fixed shape. I can't do that. I don't know how big this is. I'm going to have to guesstimate. This and this. Line. Need to make this as big as that. Give me some granularity here. Too small. Why isn't this changing? What am I doing wrong? That should have been enough to... Oh, I'm too big. There we go. 171.15. Getting pretty close. That's good. Okay. That's 171.3. Okay. We take this and this. Line on this, there, and there. There we go. Now we take this, and we extend it 8. 56.75, 56.75. Let's see if that works. Yep. Our channels are there. Oh, we deleted our dimples. That's because we have to do a progressive merge. We need this, this, and this. And this. Nope, and this. There we go. Oh, straight up don't need this anymore. Yes, I do. No, I don't. Yes, I do. No, I don't. Let's include it. Okay. We take this and merge it. This. And we bring this over. Align it. Oh, it doesn't matter. Get there. Now we can make this taller. Now we have room. Eight millimeters should be plenty. Okay, join. There we go. Now we have a hole here that will accept this. So this will actually fit right on top of this. And oh, you know, if we're gonna do all this goddamn work for this, I might as well. No, this can. Why make them buy glue? Oh, I do have another problem though. This is not going to print. I have to make this a bevel because this will not print vase mode. Do you know how we do that? We use another Taurus! We don't have to, though. I could also just use a cone. Yeah, I could use a cone. I'll do that with a cone. Although I wonder if I should print the bottom with infill. Just for weight. Yeah, I am going to do the first few layers with infill. Because at the minimum, you can make a little sandbag and drop it in there. We'll put a rock in there to weight the thing down so it doesn't, fall over and bounce around and blow over in the wind. So I'll do the first, 20 millimeters with infill. I'll see how long it takes to do all of this with infill. Maybe do 5% and then go to 10%, 15%, 20% to do this top layer. So that it'll print this part correctly. But no matter what, I'm adding a bevel, so I don't need to. Okay. Now what do I want to do? What do I want to do? It doesn't matter. Because it's going to be equidistant. I'll do this right. Do it right. So how do we do this right? We just drop a cylinder. Come here. I need you here. Maximum number of sides. I need you to be 4.5 by 4.5. And we're going to just make you really tall, if you'll let me. Why can't I pick that? Wait, it's being a real douche sometimes. Okay. Do this. We bring you 4 millimeters. 4 millimeters brings the bottom. And then I go negative 2.25. So 432, 1.75. 1.75. And we center. Like that. Now, how thick is that? Not thick enough, so we're going to go through and through. Okay. And there's an easy way to do that. We just do this. There you go. Sticks out both ends. We're good. Then we take this, we duplicate it, we rotate it 90 degrees. There we go. We have our 4 holes to install the top of the light. Why? There we go. Now we have screw holes to screw this into this, screw holes to screw this into this. We need to put little dimples on this so that we know where to do it. So we should be able to do the exact same thing, except we're going to do 5mm dimple. 5. These are detached, yes. Yeah. Take this and this. Align, anchor, there. Come on. Align this and this. Anchor this. Put it there. Now, 4, 2.5, 1.5. Take this, and we lower it. Minus 1.5. This needs to come out a little bit because we're adding a dimple. That. That is bigger. I can use this as a tool. Control D, hide. Give me my ball. Give me this. Control D, rotate 90. Control D, Control D, Control. That's it. 4. I'm taking, select all these, delete them. That brings me my 4 balls. Right there. And there, and there, and there. Join them. Restore. And join them. And there we go. Once again, we have the 4 key points. So we've keyed the location where you need to drill a hole. And we've created a dimple to make drilling that hole really easy. What you do is you'll drop this on top of this and put 4 screws in on the outside, on the inside, going out. To attach this to this. 4 screws will attach this to this. We're going to build this with some infill, because you can reach in from the top to access these screws. By filling this with infill, you can drop a sandbag inside there, keep this thing from moving around. Okay. We do still need to put a bevel on this. We also need to flip this 180. Because this needs to print in this orientation or it's not going to work. That's close enough. I'm not worried about it. I mean, in theory, I could print this. This can print in vase mode. This can absolutely print in vase mode. Yes, we're printing this in vase mode. It's going to take more work. I don't give a shit. This can print in vase mode. There's no reason not to print this in vase. No, I can't. The holes. The holes are the only reason we can't print it in vase mode. I could put dimples on there. I like vase mode. I gotta think. Think. Is it worth the effort? Because that's a lot of effort. I could put dimples on the inside and the outside. And that would tell you where to, punch your holes through. And then you could still use the screws. The only problem is that, well, it's going to be printed with a 1mm nozzle. So it will be pretty stout. This absolutely could be printed in vase mode. All I'd have to do is bevel this edge. Since they're going to screw together, it's okay if it flexes a little. They're going to screw together. Think. What do you want to do? Fuck it, I'm doing it. I'm going for all this effort. I might as well do it all. There's a pretty easy way to do it too. I only need one location. And I don't need this here because I can do that. But what I need is more balls. I need to stick you there. First, I need to put the work plane there. Let's make sure I do it right. I need to stick you there. We're 90 degrees, so we're okay for work plane. I forgot about that. Yeah, we're okay for work plane. We're 90 degrees. Okay. 6, 5. Okay, take this and this. Align. Anchor. This way, and that's good. So now I just need to take this, make it a dimple or a hole. I need to move this outwards to create a dimple here. And then I do this again, move this one out here, and I create a dimple here. I need to keep going until it's larger. And when it stops getting larger, I stop making the dimple. Okay. Delete this. Okay. Join these together to make them easier to manipulate. Do our master ring here. Radius, sides, scale it a little bit bigger. Align, anchor. Here and here. We take, do not want you to do that. Way. Take you and you. We control D. Do a 90-degree rotate. And duplicate. Okay. Delete the master rings. Not what I wanted. That's okay. And then we join, actually just to make our lives easier in the future, like this, 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 and this. Join them together. Join them with this. Now we have our screw dimples. Now we need to get rid of this beveled edge. We do that with a cone. Max the number of sides. Create a hollow. Jack the shit out of the size till we are bigger than our tool here. There we go. Now we align them like this. We take this and we rotate it 180 degrees. And now we, oh, that's not going to work. Yeah, I'm going to have to scale this down. I'm going to make this the same size as the inside of that. Mm-hmm. Mm-hmm. That. Am I intersecting or not? I don't think I am. I think I can shorten. No, I can't do that. I have to do it this way. There we go. That'll work. Oh, no, I cut into it. See how I cut into this piece here? Can't do that. Oh, no, I kind of did. Okay. How big did I make this disc? I don't remember. I could make this just a hair bigger. Am I chopping into my part now? I think I am. Can't tell if I'm eating that part or not. Oh, I am. Definitely am. Oh, wow. Okay. There we go. Work. It's an asshole. Oh, I think I know what I did. Yeah, there it is. Oh, I forgot about that little issue. Yeah, too big still. I could fix it if I knew the diameter, but I'm too lazy to figure out the diameter. How could it jump so much? Oh no, it's not jumping so much. It's shrinking. There we go. Okay. Okay. There's that. Let's make it just a hair bigger. That was not right. Okay. Am I punching into it already and I just don't realize it? Yes. I didn't realize it. Or am I? Why is this so hard to see? I can't tell if I'm actually penetrating it or not. Oh, I'm pretty sure I am. I'm pretty sure I can see it right there. Wrong piece. I think I'm still penetrating. Okay, I think I got it. Let's find out. I think I'm still penetrating. Oh, maybe not. Oh, yeah, see, overhang. That has to go away. I need that to stop looking like that. There we go. You see it disappear there? I'm pretty sure I just saw it would disappear. Okay. There we go. Now we have vase mode intact. It's screwed up. Oh no, it's still too big. See that? Still too big. Interesting. Amazing how tweaky it gets, isn't it? This is what you get for not being parametric. Why don't I see the dimension? There it is. Way too big. Oh, maybe not though. Nope, it's not. Let's see what that does. We are a smidge. Oh God, such a tiny smidge. I could probably just change the height and divvy that up. Yeah, probably do it. No, it won't do it. I do still need to change this. I just need to get less than a millimeter. And then the nozzle diameter will take care of it. Yep, there we go. Now we have a ledge. The ledge is fine. Just fine. The nozzle diameter will take care of that. Okay. Now I want 3 bottom layers. So that's 2.4 millimeters. I have to take this, do this, Do this. And do this. 2.4. .02. Okay. You need to slice all the way through, just like that. We align this way. And that creates our slice. So now we are, we're going to fix that. We do not want to be there. How far do we want to rotate out of sync? 15 degrees is enough. Just do one click. We just don't want these slices lining up with our tool marks. So 15 degrees. So I got to remember if I need to make a change, I need to go backwards 15 degrees. Actually, I'll rotate the whole thing backwards 15 degrees and move the slices. Okay. So that takes care of that slice. The next thing I need to do is take care of the next slice. And the easiest way to take care of that slice is to just make another slice here. Do I have a proper face? It's the easiest thing to do is to find the face. Let's make you taller, make you skinny. Okay. Grab the three of you, align yous. That gets us to that face right there. So you put a work plane right there. Now I can delete this. We're on this plane right here. Now we take the square, drop it on our work plane. We make that square as tall as the entire object. Ooh, that's getting real squirrely. That's fine. We'll do this all the way through like this. Change this to 0.02. Then we no longer need that work plane. We go back to this work plane. Turn this into a solid. Okay. We take this and this. That's not right. That's not 90 degrees on face. I think that's because it's rotation. What? Wait a minute. Whoa, 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 whoa. Why is that's not even close? Whoa, that's not even close. No, something's wrong. Let's go back. Go 15 degrees back this way. Oh, wrong way. 15 degrees back this way. What did I do wrong? I think I need to do different. Control D. You over here like this. Okay. In the correct spot. Now I take this into a solid. This, we put it right on here. Right on the face of that one. This. This. Do I do it this way or this way? Doesn't matter. Take this and this, join it. I turn that into a hole, and I shift it 2 millimeters this way, 1.9 millimeters that way. Okay, there's my rib. Okay. All right, I got the rib. Another master ring. Radius. Enlarge just a little bit. Align with anchor here and here. Because we're printing with a 1 millimeter nozzle, I don't need that many ribs. Control D. And I think 15 is enough. Okay. Get rid of the master ring. Hide you. Delete you. Restore you. So we have the one through and through, and we have our ribs. They're all raised up 2.4 millimeters for our 3 bottom layers. Hey, Seymour, how are you doing? Okay. Now, I would like to get the ribs off of the important points. So 225, 225, right? These? Yes. If I go 15, what's that do? Okay, it misses that. It gets that. I think I'm actually okay with that. What the hell? Oh, I can't do 15 degrees because the ribs are on 15 degrees. Duh. Let's go 8 degrees. There we go. Do I miss everything? Oh, yeah. I miss everything. Good. Okay. Let's get rid of you. Join. Phase mode. Yes. Got it. I could do a little bit better, but you know, so I'm satisfied with that. Let's make it nicer. Let's make it nicer. Let's see. Okay. If I want to put that in the middle, that means I need to go 7.5. In either direction, shouldn't matter. 7.5. It's not what I want, though. I wonder why it's not what I want. If they're in the 7.5, I have to go 15 off. I can't do 15 off, though, because that's go. No, that'll be fine. So if here to here is 15, then here to here should be 7.5. 7.5 should be the correct number. Why isn't that working? 7.5. Why isn't it centered? $7.5 should have centered that. Oh no, wait. Oh. Yeah. 7.5 should have put that right in the center. Because if I go 15, oh, it's going 22.5. Idiot. I need to go 11.25. 1, 0.25. There we go. Now we're centered. I thought it was 15 degrees. It's 22.5 degrees. Derp. I really want this cut to be on a different one. So, let's go 22.5. Again. So we are still centered, but now our cut is not going through the opening. Centered, centered. None of our important features are intersecting any of the cuts. Because it's going to make them bulge. The ringing is going to make them bulge, and you don't want that. What are you grabbing now? Of course, you're going to grab that off the screen. It's nowhere near you, but you're going to grab that, right? Okay. That's phase mode, baby. And to test the fit, the easiest part to modify is the bulb. So what I could do is I could print all this just as they are. Let's get rid of this. And then I can just print just this bottom part of the bulb. Just this little tiny itty bitty bottom part. And when the I can test the fit. And if it doesn't fit, I can adjust the size of this until I get it to fit. This way I don't waste much plastic. Actually, I could print this first. It'd be risky, but no more risky than printing a test print. I could print this until it gets past these balls, then pause the print, and while it's sitting on the print bed, test fit this right on top of it. That should actually work. That actually should work. Although I do need to make a couple changes. So this piece is done. This piece needs a slight change. Just to make it a little bit easier, we're going to bevel the bottom edge of this a tiny bit. And that's approximately 120. So here's how you do that. You take a cone. You max out the sides. Then you take a cylinder. And you max out the sides. Then you align you turn this into a hole. You align these two bad boys. Like this and like this. And then you join them together. Then you turn this into a hole. Then you scale the living shit out of this and rotate it 180 degrees. And you bring this stupid chunky thing down all the way down here. There you go. You just scale it until it's bigger than that. Align. You and you. There we go. Now you just use this. Add a wee. Oh, we don't want to do that. So we do this. Take this, bring it down below this, and then we shrink it until it does what we want. Just like that. There. And now, make sure we're not out of bounds. And now we have a bevel. That bevel will make sure that this will insert into that really easy. Won't give us any trouble. Or you die! Okay. This needs to be cut. Because it is 600 millimeters tall. So that means I need to take something like this. Like that. And like that. We take this and this, we align, we anchor this, center, center, and bottom. Like that. We scale, we continue to scale this, make sure it is bigger than our piece. Because we need to split this in two. Okay. And we make this, well, I might as well make it 300. Because then if a person has a 333 printer, they can still print this. If I make the first piece 400, then a person with a 333 can't print it. Now we Control D, come down here, and we invert. Why? There it goes. Stop being a nudge. We invert like this. We take this whole mess, we Control D it, we put it over here like this. One of these, we delete this. One of these, we delete this. Now we join them. This gets joined. Oh, we're out of bounds. Oops. See how it's dark? Letting you know you're out of bounds. Join. And join. Bingo bango, who's your daddy? Okay. That will also bring these within the envelope. Although, I could also do this. If I export them like this, then if a person has a printer big enough to print this, they can print it all as one piece. Like if you have a 600 millimeter tall printer, you'd be able to print this as one piece. I almost have a printer that big. My CR10S5 is 500 millimeters. I'd only have to extend it another 100 millimeters. I might do that. Not now. So, bulb, bottom, bulb bot, port, STL, and then this one's going to be bulb top. Bulb top, port, STL. Now let's see if that actually works. When I open up Simplify 3D, I should, in theory, please stop doing that. Yeah, shut up. Should be able to align selected origins. Yes. Now, if you have them aligned, you group them. Now you can interact with the models as one. And yeah, that makes a perfect join. So if you have a 600 millimeter tall printer, you can print this as one piece in theory. Why is that not aligned? That's slightly off. Why is that slightly off? Yeah, slightly off. actually think I know how, but it's because it's an irregular shape. And the bottom must have a slightly offset dimension. So when I align these, they don't perfectly align. I can show you. 297 by 297. Yeah, see? 290.78 by 291.02. The shape is slightly irregular. I know how to fix that. Okay. The way we fix that is by using a master ring. Let's see here. This one is symmetric. This one's going to be symmetric. This one's not going to be symmetric. So this one is the one that needs a master ring. Yes. Sides. This and this. Align this with this and this. Okay. So now we should be able to take this and do this. This should be okay. 297 by 297. All right. Now we take this and do this. We take this and join it with the master ring. Get it inside bounds. We take this and this, align, center here, this and this. Now we take this, disconnect it from the master ring. Now we save it. So the top one's the only one I have to redo. The bottom one should be okay. Okay. Now these two should align. Refresh. I always overshoot. So annoying. Shut up. Shut up. Do as you're told. Or you will be bitten. And then we group. Center. Uh-oh. The origins didn't line up again. What the hell? Ungroup. Align. Uh-oh. It didn't work. Oh, I moved them. You idiot. It's not relative to each other. It's relative to the grid in Tinkercad. I gotta resave the bottom, too. I'm a dummy. B-O-T. Refresh. Yeah. Sure. Enter. Who cares? Close enough. That's a micro. That's such a tiny difference. It's almost not even a difference. Okay. Now, will it slice? We'd go to a 1 Mach factor with a 1 millimeter. This. And we could probably get away with a 0.8. Let's go 0.6. It'll look nicer. Just shut up and do it. 11 hours and 500 grams of plastic. Nice. Half a roll. Oh, nice. Now, I might actually want to do this first part at 0.2 millimeters. Well, 0.4. No, I'm actually just start with 0.6. As soon as you hit here, 0.2 until here. I just leave it all 0.2 until you get to here. And then go back to 0.6 again to do the rest. Okay. Do we have any glitches? Travel, retraction tool head. Nope. 0 glitches. So you'll notice a glitch because you'll see a red line for a travel move. And also, this tool head should basically stay in the same spot the whole way up. See how it's basically not moving? How's the top look? We'll go down to 0.2 millimeters for the top too. We might even go down to 0.1 millimeters for this top part here. But I'm betting 0.2 will work fine. Okay, so now if you have a big enough printer, you can just align origins, group, and you can manipulate this as a single piece. For the rest of us muggles who don't have printers that nice. Okay. Bulb bottom. That's it. Now we create our parameters. Tools variable. Bring it over here. Hey, DeWitt. How are you doing? Lip sync is out by full sentences. All right, let me reset OBS again. I'll be right back. Of course, I keep scratching my hair, and so when I do that, my hair goes. All right, lip sync better now? Excellent. Now, we're going to bring this down here. Yes, 1.4. That can't be right. That's got to be a few millimeters up. 2. Yeah. 3. 4. We want to do this in layers divisible by 0.6. So 6 millimeters would be perfect if we can do it. No, that means 5.4. There. We're going to add a layer there. Then we come up here. We go 38.4. Actually, we can, yeah, let's do 38.4. So we know it's evenly divisible. Actually, I bet you 38 would be okay. I go 37? Nope. So 38, add, and then we are good. So this section here, we need that to be 0.2. Slice, select all, continuous. There we go. So we do a 0.6 millimeter layer height. Then we switch to 0.2 to make sure this print's nice and clean with the overhang. Then we switch back to a, oh, it broke. That should not have done that. I specifically used the correct sizing to avoid that. Did I screw this up? Layer. Nope, it's 100%. That should not have done that. Let's try 0.5. It glitched there, and it shouldn't have done that. Why are you being a nudge? Oh, wait a minute. Optimize for fastest, that's good. That should be off. That might be what's causing it to restrict right here. Still a little gap there. That gap should not be there. I mean, I know how to make the gap go away, but I shouldn't have to. I shouldn't be doing that. I mean, I know if I lower this. No. Cancel. I know if I lower this, that'll fix it. But I should not have to do that. Oh, I forgot it likes to do that too. If you overlap layers, it glitches and it adds the skirt. Huh? All right, that got rid of it, but I should not have had to do that. I hate when it does that. Okay, now does this overhang look too much? No. With a 1mm print, that should be okay. Let's make sure it doesn't jump. Okay, it's not jumping. Oh, it jumped right there. But we're overlapped enough that we should be okay. Now, the only problem with doing this is joining these together is going to be... Although it's 1mm thick, so it shouldn't be too bad. But man, is that going to be a nightmare trying to join these together. Ooh. Boy, is that going to be a pain. What I should really do, even though this would affect the look, is I should print this inverted. I should print a lip on here and a lip on the top part, so you have a larger glue area to join these two parts together. That's what I should do. Because you're already going to see a line here, and that's going to annoy the hell out of me, but there's nothing you can do about it. If you want to make it this big with a regular printer, then we have to. You would need a custom printer to make this bigger. That is going to be a nudge to join together. Oh boy, is that going to be fun. Well, it is what it is. That's what you're going to get. Export. Bulb bottom. New folder. Giant. C9 white. Okay. Let's save the factory file. Bulb bottom. Yes. Okay. Get rid of you. Get rid of you. Bulb top. Let's see here. We're going to make this 0.6. Custom zones. No. Okay. Tools. Variable. We're going to put a variable right about there. 284. 284. Add. Okay. And this will drop down to 0.2. Layers. 0.2. Select all. Good. Yeah, that's fine. It's a little glitchy there, but that's in the model. That's not in the slicer. Oh, we got another gap. Oh, that's why it's gapping. It's because this layer stops here. Because there's such a dramatic difference between the two. Oh. I know how to fix that. I actually know how to fix that. Okay. I take this and I control CV. Edit. Align model origins. Group. Enter. Okay. So this process gets this model. No, 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 no. Click model. That one. And this you see, when I should have, I can't believe I never realized that until right now. It's because the first time I actually saw that. Okay, so the slicer should be smart enough to have handled that. But it's not, and they're not updating it, of course. So here's the problem. You're telling it to print at 0.6 millimeters, and then you're telling it to print at 0.2 millimeters. But the problem is this layer is 0.6 and this layer is 0.2. There's a difference here. Okay? So you'd have this is where you're stopping, and then this is where you're starting, because the continuation is shorter than the start. So obviously it says, I can't do that. You know, I'd be going right through the other part of the model. So what it does is it starts where the other one left off, and you end up with that gap. And that's because I'm telling it to go continuous. I have to use two separate models so that it actually finishes the first model. And when it finishes a vase mode, it thins that last layer to create a flat top. And that flat top will be where the 0.2 will start. So now this should work. Select all, sequential, 999. This should get rid of that. Oh, I forgot to take off the stupid. It should be smart enough to realize there's nothing there, but it's not because I'm doing a little trickery to make it do this. And there we go. We still have a gap, but you can see it's flat. I wonder why we still have a gap. I know how to fix that too. We just lower this down. So 283.8. There we go. Gap gone. You just force it to, treat it right. And now it creates a flat top here, and then it begins to point to on top of that. I knew about this before. This is why I can't do it in Prusa Slicer. Because Prusa Slicer won't let you do this. It's a workaround, but it's a workaround that works because it lets me do it. If you try to do this in Prusa Slicer, it just won't work. Nope, we need top. Did I forget to turn the skirt on? No. Ooh, I gotta put that skirt closer. Because I forgot we're like right on the edge here. Additions. Yeah. Let's go 1 millimeter away. Woo! Just fits. Then save. File top. Okay. Let's delete this, Let's bring in our next part. We're building these, by the way, DeWitt. These Home Depot 3-foot tall Christmas lights. I'm designing ones to make myself. And I'm doing a nice job at it. I'm just, instead of going crappy, no glue. The only part you have to glue is the bulb. I mean, I could make the bulb screw together. I could make this a little bit better, but the more I add to it, the more you're going to see the seam because you've got to put them together. So gluing is going to give you the best chance of having a minimized seam that you don't see. I'm even tempted to say, print this in transparent PETG and then paint it. It's not an adaptive layer problem. Adaptive layer will work, but Prusa Slicer creates the gap, just like you just saw there. Except Prusa Slicer will not permit me to overlap two models like that. Prusa Slicer doesn't have a variable process routine like Simplify 3D does. And that variable process is what allows me to do that. As soon as I tried to overlap that gap, Prusa Slicer would say, nope, I'm not doing that. Although, I should try it. Maybe Prusa Slicer will handle that better. Like maybe it'll realize there's a gap there and it'll handle it better. Or maybe it'll handle the transition better. I don't know. I will try it though. Okay. So bulb, top and bottom, both look good. They both slice correctly. I think we're good. Now we need to bring out this piece here. And this is going to be, we're going to call this bulb interface. So INT, bulb interface, STL. Yuck! I hate when I get snot like that. Alrighty, bulb interface. We're going to do this at 0.4. Okay. We're going to increase this a bit. Okay. And then we need 3 bottom layers. I was going to do that at 0.6, but I don't think 0.6 is going to work. 2.4, that's a problem. Is it a problem? Let me think about it. .4. No, it's not. It's still evenly divisible. 6. So if I do 6 bottom layers, that'll work fine. I don't want to do 6 bottom layers. That's going to take a... Oh, no, it's not. It's not much. It's only a ring. So it's not much. Okay, it's fine. It's fine. All right, it looks like it was clean. It looks like we're going to have to go down to 0.2. That looks a little open right there. I don't like that. Yeah, I think we're just going to do the whole thing at 0.2. We'll do the beginning at 0.4. Yeah, I think we're going to stick with 0.4, 0.2. 0.2. Let's do 3 bottom layers. All right. Tools variable. 2.4. 2.4. 3 bottom layers. 0.6 millimeters tall. Let's try that. Oh, wait a minute. No, that might be okay. Continuous might work. We have a gap. No gap this time. Well, at least not there. Really? Oh, you bastard. I was trying to sneak through the model. No problem. Yep, no problem over there. No problem over there. Jumping around is okay. Although I would rather have more perimeters on this first layer. So let's turn off vase mode and do 3 outlines. It's a 1 millimeter nozzle. 2 outlines is fine. There we go. Nice. 2 perimeters plus the infill. Patching back and forth. I don't see any gaps. Okay. All right. Let's make sure the rest didn't glitch. These are just dimples, so they're good. Okay. All right, let's test for glitch. And we have no glitch. That is wrong. There's one extra layer there. So I need 4 bottom layers. That shouldn't be. 6, 12, 18, 24. It is 4. It is 4. I screwed that up. I didn't want to do 4, but that's okay. It'll be 4. There we go. Good. That only takes 155 grams of plastic. We have our vase mode. It's intact. We're not punching through the walls. It looks like good fusion. See how you see the slight overlap there? You see it here. You can see how it forms like a little triangle here. And you can see how this triangle overlaps that triangle. That's what we want to see. Ooh, this looks nice. How does this print? That looks good. We have our little tiny glitch here, because I didn't get it perfect. But you can see it's still within the width of the nozzle, so we're good. What you'll do is you'll drill a hole through these dimples, and then you'll use a screw. Now the only bad thing is the screw might stick out. It won't be far, but the screw might stick out a tiny bit. I could have the dimple pop out instead of in, and then your screw would just push against the outside, but I don't want to do that. You can only see me. I didn't switch. Oh, I'm an idiot. Sorry. So, you drill a hole through the 2 dimples, and then this will fit right on top of the base. And then the 4 screws will hold this in. The reason we're printing this as a separate piece is because it has more complex... Wait a minute. Oh, because I need this to be top layers. I need this here to be top layers. If I didn't need this to be top layers, we could print this all as one piece. Because this is all vase mode compatible now. But because I want this to look nice, and I want this nice top layer to be here, because that's the top of the bulb. What? I don't understand what you're saying. Oh! I just noticed that you were saying the same thing about the screen! I'm sorry, Big Joe. I need to figure out a way to do that, because I do forget. You know what? Actually, what I do need is once I have a multi-monitor set up, I'll have this on its own screen, and I'll be able to see it. See, the problem is right now I can see it, but when I do this, I can't see it. So I don't know it. But once I have like a triple monitor set up, then I'll be able to have this on its own screen. And then at some point I'll glance at it and see it and go, oh shit, I'm on the wrong screen. That should get easier. Yeah, this looks good. So the way this will work, this is actually the top. This is the bottom. The bulb will insert into this bayonet mount, and you'll rotate the bulb until it pops over these dimples. And when you're in between the 2 dimples, you know you're in place. That's it. And this way you can just take the bulb and go pop, and pop it open, take it out, to store it and to put it away. Now, another way I could do it, let me save this. This is good. I like this. Export, bulb int, yes. File, save factory file, bulb int. Okay. The reason, another thing I could do, I could eliminate people with 3x3 printers or have 2 separate sets of files. Did they actually take one down? God, really? They're shooting down drones? Give me a break. Although, you know something? No, and actually I disagree with that now. That thing's a behemoth. It's a hybrid convertible drone airplane with a gasoline engine on board. That thing's heavy enough to hurt somebody. So yeah, if it's actually flying over people that I could see, then it's not from China. Come on, it's just somebody messing around or somebody testing something or one military branch not talking to another military branch. But what I could do, this might not work actually, I'll have to see, but if I move this cut point up to 400 millimeters, that's going to be about here. It's still too big, never mind. I was thinking then this piece could insert through the bottom here, and you would definitely have a seam, but it would be a stronger joint. I don't know. I'm trying. The problem is when this thing lights up, you're going to see this seam when it lights up. And if it's just a single glue seam, it's not going to be too bad. But if I start adding structure here to make this assemble better, that's going to really stand out. You're really going to see it. And ideally, you would print this in one piece. I'm still surprised no one's done that. Why hasn't no one made a 336 or a 446? I mean, this is only 300 by 600. I mean, it's only another 200 millimeters. Just take a CR10 and make it 600. I'm just surprised, considering how cheap it is to make a CR10, and considering you only have to replace 4 components. The 2 uprights need to be longer, and the 2 lead screws need to be longer. That is the only thing that needs to change. Wait a minute, Chris, the wire needs to be longer. No, it doesn't. Just use the longer wire on both. Okay? Make the longer wire on both and have 2 different clips. Clip it here if you're doing the 400 millimeter printer. Clip it here if you're doing the 600 millimeter printer. But it would be nice if somebody made a cheap, simple upgrade just to change a CR10 to a 336. Because 336 would let you do so much. Or even better, the Chiron. What? You have to leave space for ventilation in the bushing, or are you going to set the turkey on... What? I don't know what that means. Okay. So this is done. It looks like it prints okay. This is done. It looks like it prints okay. I do need to make one more change to this. So the first thing I'm going to do is I'm going to duplicate this, because this needs to be laid on its side. Like this. First of all, how big is it? We're good, 259. Bulb. What do you call this? Clip. Okay. But just the people worrying about the drones, man. Come on. I still have issues, neighbors who get angry when they see a drone up in the air. I'm like, okay. This cell phone has a better camera than a drone. By nature of what a drone is, they have wide-angle cameras. That's an LED bulb. It's running on AAA batteries. It's not going to get hot. It's just... But my daughter is sunbathing out back. I don't care. I'm going to look at your daughter all day long from my drone, and not only will I not be able to tell whether she's male or female, I'm not even going to be able to tell whether she's naked or not. It's too far away. Your daughter's going to be about 15 pixels. Okay? If the drone is close enough to harass your daughter, it's close enough for you to hit it with a baseball bat. Go ahead and hit it with a baseball bat. Okay? Okay, basically, the way I would make the rules, if the drone is below the roof line of the house, you're invading somebody's property. Get out of there. All right? If you are above the roof line of the house, I consider that to be public airspace for the purpose of drones, and they're high enough to not be a threat to your privacy. Okay? I mean, your local counties are using Google Maps to spy on your property and decide if you have a planning and zoning violation. And you're worried about the kid flying his $300 toy drone? Get a life! Anybody capable of flying a drone that's a threat to you, they're not going to care whether you have a problem with it. Because now you're talking about military or government. And ask them if they care. They're going to say, fuck you. Okay? Just, oh, no, I'm sorry. Yeah, this is going to be battery powered. We're going to, I can show you actually. I'm actually going to power it with, come on. We are going to power it with this. I got this for a couple of reasons. One, it's got nicer wire. It's got brighter emitters. And it's 33 feet and 100 LEDs. So I'm just going to loop it back and forth, back and forth, back and forth until I get the light that I want. I'm actually thinking about making a change to the socket for just this purpose. The shed, I have about 15 blocks printed, but I am so bad financially right now that I literally can't afford to run the printer. Running the printer would cost $30 a month, and I don't have it. I just don't have it. So until my financial situation improves, I can't do continuous printing projects. I have the plastic. I got tons of plastic. I got a case of 10 kilograms right out there. I just can't afford the electricity to run it. I can't. Running a CR10 size printer 24/7 is $30 a month. Oh, I'm sorry, I didn't switch again. So this here is what I'm going to use. I'm going to use warm white because warm just makes it look nicer. If you want brighter, use the cold white. It'll have a little bit more lumens than the warm white. But if you want that oldie, incandescent Christmas light look, use the warm white. This one's got a remote control. It's got a timer function, and you can even do modes, but that's not going to be, there's no point in that for this one here. To extend the runtime, you can use some 3 AA battery boxes and wire them up in parallel. So that what I would do is I would get 2 more and run this on 9 AA batteries. That should be long enough to go like a month. I don't know how long this is going to go. We'll have to find out. But 3 AA's, probably not a month. Or you can wire it up to mains power. You can use a light bulb socket, and you can do that too if you want. I'm going to make a different mount for that specific purpose for people who want to use mains power. And so I'm going to make this whole thing adaptable. Yeah, the whole point though is that I'm having trouble thinking. I don't know why. With the amount of heat that this is going to generate on 3 AA batteries, it's not going to get hot. It's just not. And if you're running it on mains power, if you do what I say, you're going to be using a 1 or 2 watt bulb. So you're going to produce at most 1.6 watts worth of heat. That's never going to overcome the BTU transfer to the atmosphere. You're fine. You're never going to get hot. And then the whole thing's designed to screw together. So there are dimples in this part here for you to drill a hole through. And then there are holes. There are holes in this part so that you can just reach inside and put a screw in. And this will all just screw together. I'm with the exception of this here, I'm trying to design this to not require any glue, so that it's serviceable, repairable. The only reason I'm not doing that here is that it will ruin the look. It'll really ruin it. If I put a seam here, it's going to mess it up. I mean, if I put a joint, a solid joint. I'm just hoping that the 1 millimeter thick extrusion will be solid enough to be able to glue this together without a problem. We'll see. I should probably, did I forget to change again? No, I'm here. I should probably put, I might do this later, we'll see if it needs it. I should probably put a little dimple here and here. Oh yeah, I'm going to print one. I should put a dimple here and here as alignment markers, since we know this is not exactly straight, but it's only 0.1 off, so you're probably not gonna, it's probably not gonna matter. So that is loading here. Okay, remove this, bring this up. We want to bring the clip in. Okay. Clip. We do not need some layers. We're going to do this in, I think 0.4 is going to be enough for this. And we're going to do 3 top layers, but only 2 bottom layers. And we're going to do 2 perimeters. We're going to do infill of 20% is a lot, but it'll print nicer. Let's leave it at 20% and see what happens. Okay, that's okay. I like that. It's the direction I want. Oh, no, it's not. Yes, it is. Good bridging direction. Okay. Where's the infill? Oh, I got phase mode turned on. So 4.5 hours, 120 grams. That's not bad. I'm okay with that. Oh, that's plenty. Oh, I don't even need that much. I'm going to try lowering that a bit. I don't think I need that much infill. Length. Oh, it's because we're rectilinear. Rectilinear grid. Not enough. Okay. It's because it was rectilinear. 20%. We are at 200 grams. Okay. Yeah. That should bridge okay. So 2 layers, infill, layers, and this, it's shaped correctly to fit right against the device. And once you put the holes in it, your screws will go right into here, right into here. And because it's so big, you'll be able to reach your hand right in there and just screw it in. So bulb clip, yes. Save factory file. CLIP. I love the new keyboard and mouse. It's really nice. I got a really nice Logitech set used. The return, open box. But it's really, really nice. So it's got the the pop mouse. The nice thing is that they're well, first of all, it's Logitech, so it works. But also it's dual mode. So you have the, I think it's in here actually. You have the dongle to plug it into the computer or Bluetooth. And because this has Bluetooth, I don't have to waste a USB port on a mouse and keyboard. But the problem is the letters are shiny. See how the letters are shiny? And when it sits on the desk and it's illuminated, it's hard to read the letters sometimes. Because the light shines on the letters and makes them shine. So you have to, like, this angle, beautiful. This angle, you can't even see the letters. But otherwise, not bad. It's a nice keyboard. I would like a brighter, hotter pink, but that rose pink is nice. I like that. It's a elegant color. It's nice. Okay, now we need to fix this before I print it. So I can delete that. Let's hide this. Okay, let's break this apart. Oh, that's the dimples. Let's break this apart. Still not done. Break this apart. There. Got it. Let's change colors so we can tell the difference here. Let's see, are these all joined? Okay. Those are not joined. Those are not joined, okay. These both should be joined. I should be able to do this. Join that. Okay, and then I should be able to join this. Okay, so I want to print this in vase mode too, but there's a big problem with that. This does not work. Can't get rid of that completely because it's part of the design. It's not going to look right if that's not there. But what I can do is bevel that. That's what we're going to do. So, the way we do that is the same way we do the other one. You take a cone, you max the sides, turn it into a hole. You take a cylinder, which you don't have to max the sides for, but we're going to anyway. Sides. You then take these two and you join them. After you align them together. Ink, ink, and you join them. And then you turn this into a hole. See? I have a deburring tool, essentially. Why deburring tool? Because we're going to deburr the edge of this cylinder. Actually, I don't need to align anything. All I got to do is do this. Yeah, good. So take this and this, align, freeze this, bring that other part into focus. And now we just do this. Just until we nip the edge of this. Let's bring that down. Like that. You just adjust it. Don't worry about what it does to the other piece. That doesn't matter. You'll see in a minute. That's why I had to separate them. Now I take this and merge it. There. So now at least you still have that little step there. I should bring that down just a hair. I should bring it down just a little bit. Just to get rid of that lip there. Okay. And join. Did I go too far? Nope, we're good. There. So now we have phase mode compatibility. Now I take these two parts, rejoin them. And now I can print this in phase mode. Here's the dimples. You drill a hole through there with a drill bit or a hot knife. And then these have hole dimples in it. You drill a hole through it. And then you feed the screw in from the inside here through that hole into these holes. And that will hold the two parts together. Easy peasy, yummy squeezy. And now this is the bulb socket. S-O-K. Port. Okay. Remove bulb socket. Alrighty. So what we're going to do here we are going to go 0.6 millimeters. No top or bottom. 3 perimeters just for strength. Infill, grid, 20%. Yes, that should be okay. Okay, tools, variable. We are going to make the bottom 10 millimeters thick. I think that's plenty. Let's go 15. Yeah, I like 15. It looks better. You'll see why in a moment. Why did that do that? You little slime bag. You little dirtball. Stinky computer. Whiny wanker. Add. Now hit OK. And then we switch to phase mode. But we're going to go 0.4. One, this. Although these might be shallow enough to do 0.6. 0.6 will print a lot faster. And let's find out. That might be okay. That looks good. That's our interface. How's this looking? Yeah, I think that might be okay. With a 1 millimeter print and the curve looks okay. Yeah, we're good. I think 0.6 is good. It'll only take 10 hours and 400 grams. So you should be able to print this entire base with 1 roll of filament and the bulb with 1 roll of filament. So there you see we have our grid in the bottom there. Now, the whole purpose of that is to make sure that, well, first of all, the bottom is sturdy and not too flexible. But more importantly, this will, I don't know, it's so hard to think sometimes. You could put stuff in here now. Okay? So you could put a couple bean bags in here, a little bag of sand, a brick, anything. You could stick weight in here to make sure this thing stays put and doesn't blow over in the wind. So now you have a base to support it. And even though this is phase mode, it's being printed with a 1 millimeter nozzle. So it'll be fine. What's this? New record what? Near record what? This is kind of cool. I actually kind of like this news thing. Every now and then it pops up something interesting here, so I've decided to leave it. Okay, export. And this is the bulb socket, yes. File. Save factory file as. Yes, okay. And bulb stock. Oh man. I am on the right screen, right? Yes. Okay. Did I forget anything? No, I actually like this beveled edge. It looks nice. I'm glad I did that. That looks really nice. I probably should go to 0.4 here. Just to make that stronger, because that's going to be a weak point. But I want to try it first and see how it works. I can always just reslice and do that at 0.4. The more of the layer, the taller the layer height. One of the things when you're doing vase mode is that your layers look kind of like this, actually. Here's a good way of describing it. So here's your first layer, here's your second layer. You have perfect overlap, you're good. Now, in order to form an angle, you have to shift the layers like this. Okay, so each layer gets shifted a little bit more, like that. So each layer stair steps. The thicker your layers are, the greater the stair step between each layer. The lower the layer height, the less stair step, and the more bonding you have between the stair step layers. So the issue here is do I have enough bonding that this won't crack at that point if something just bumps into it? You know, so I'll test it. I'll print it out, and worst case scenario, I can just reinforce the inside with epoxy, and then just adjust the slice for the next one. This way, I don't waste one. Okay, I think I got it all, and I was able to do the whole thing in vase mode except for the clip. Now, technically, I could do the clip in vase mode, but that's kind of silly. Whoa, that was weird. I could, in theory, I could put some slots in this clip, and I could print this entire clip in vase mode. The problem is the sides will be open, and this will look better closed. So screw it. We'll leave it closed. But it is possible for me to design this. I can even design it to be closed and still be in vase mode. That is entirely possible. But that's just not worth the work for a 200-gram part. It would maybe make it 100 grams instead of 200 grams. And I'm just not willing to put that much work in to save $1. This was a technical challenge. I just like the idea that I made it work in vase mode. And that just makes me all happy and bees inside. I did it vase mode. I might do one in vase mode just for people who are weird like that. It'll kind of draw attention to the fact that it's printed. Although, no, actually, no, I'm sorry. Oh, yeah, I could. I still could. Because I could just use dimples for the screw holes instead of shafts. And then you just use a small enough drill bit that it'll bite the plastic. Yeah, I could do this in vase mode if I really wanted to, but I don't want to. All right, so the way this will assemble, Control D, this comes up here. This rotates around. I do have to make one more part. This goes on here like this. Just like that. And then this fits into this socket. So that's the whole thing right there. This screws into this. This screws into this. These two parts get glued together. This bayonet mounts into the top of this. Now, one last thing we have to make. I have to make a little hook to go on the inside of this. This needs to be, I believe, 36 sides. This goes on top of this. Yep. Join. Now, make it bigger. Let's see here. Oh, I have no way of grabbing that now. That's annoying. There's just no way to grab that. Yep, that'll work. Okay. What, pray tell, are you going to do with that? Oh, yeah. This should be 20. We are going to make this 44. 44 club. So that means 34, which means 17. 24, 22. 22. Control D. That. This. Let me do it. 10 millimeters thick should be enough. Probably too much. Let's do 8 millimeters thick. Yeah, it's just a hook. Although I hope I can fit my hand in there. I don't know if I can fit my hand in there. I should. I can use a hooky if I have to, a little hooky stick. Let's make it 8 millimeters thick. So that's 4. That's 23.61. This one. 22.56. Okay, and I don't think I need it to be this big. I'm going to change it to this big. Okay. And now we're going to take a cylinder. We're going to do this. So this is still too big. Still too tall. Although I could make this bigger. Okay, now let's make it bigger. Make this bigger this way. What I want to do is something like this. And then do something like this. Yep. Let's make this smaller. Make this smaller. So it's more of a hook with more robust engagement. Make that smaller. It will stretch over time if you do it wrong. Might make it easier if I do that. I mean, better would be to make it a clip that you would flex, but I'm lazy. Okay. Need a cylinder here. This is going to be 4.5. Rotate this 90 degrees. Why? Don't be a nudge. Okay. That goes to there. That's too long. Too close. Okay, nothing else is being grabbed. There we go. That's our hook. Export STL. that is our hooky hook. Bulb hook. Yeah, that's plenty. You know, let's unscrew that. That's ugly. Why make it ugly? Screw that. There's just no reason to make it ugly if I don't have to. Make that a little bigger. That a little bigger. There's just no reason to make it ugly. It'll look a lot prettier if we make it round. Much better. Much better. Yeah. Bulb hook. Let's see. 2 perimeters is plenty. 0.6 millimeters is good. No, it's 2.4 since we have the screw hole. 0.4. Infill. Let's go 25%. We want support for the screw hole. No top or bottom. I just have to bring the part in, don't I? Yep, that's fine. Yeah, that's good. It's good. Yep, that's perfect. Now, the purpose of this, you're going to put a screw right through the top of the bulb into this. What? Oh, we're out of sync again? Nah, I decided not to go. I missed it. It was at 2 o'clock. I was a couple hours ago. Let's see here. Yeah, that's fine. This is fine. The whole purpose of this is you screw this into the top of the bulb so that you can hook the lights to it when you dangle the lights inside. If you're going to make a bunch of these, there's a different set of lights you should use. I think I have them saved. Yeah. You want to use these. Unless you want to spend the money for the brighter ones. But this here is 14 feet. Right? So that's, you're going to wind that like 3 or 4 times around the hooks. That's 40 LEDs. It's warm white. They have multicolor and they have pure white. So if you want a little bit brighter, use the pure white. If you want that old-timey, better warmth, use the warm white. And this is $18 for 12 of them. That's $1.50 a pop. So you just use one of these in each, and you're good. And then you get, if you don't have them already, in fact, I'll put links to them. There we go. So this is the 12 lights. Why can't I pick there? There we go. Those are the 12 lights that are $1.50 a piece. That's a really good deal. If you want the slightly fancier remote control lights, or you just want to make one of these, you don't want to make a dozen of them, then use this. If you're going to you're going to need the screws to put this together, I'm using these. Only because they're cheap. Right? If you want to get fancy, use the stainless steel screws. They're about $10. But for $5, you get 120 of these. They're 8 by 3/4 inch, and that's what this is designed for. And you're good to go. Okay, and for let's see here. That's it. Still on there? Yes, good. So there's the little hook. I think I got everything. Yeah, that's everything. The only other change I might make, I'm gonna experiment with it, but I might experiment with putting I don't know. I gotta figure it out how I want to do that. I might put I don't know if it needs it. I might put attachment points here, so you can run like a rubber band or a string across the opening here, and then have something to wrap the lights around on both ends. That hurts. But I suspect the weight of the thing itself will be enough to hold it in place. Another thing I could do. No, I can't. I can't do that. See, I could print this upside down and I could put a floor in here so that the bulb will have something to sit on. But I don't think you need to. I'll figure out a way to do that. I'll figure out something to attack, because I don't want it swinging around inside there. But then again, it shouldn't really move. So I think just a couple twist ties holding your light string together, and then you hook your lights onto the hook at the top, and I think you'll be fine. I'll confirm that as I print. You know, I'll diddle with it and see how it comes out. But that's it. That's everything. You might need to I should probably put a hole in here, but you might need to nip the tip off of this, or just drill a little hole through it. And then your screw will go through that into this. So you already have the hole here. So you screw that in. If you don't want to screw it in, you can glue it in. But that is for you to hang your lights. So when you string up your light string, you loop the wires. You figure out how long of a piece you need for inside the bulb, and then you just loop it, 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 and a couple twist ties or zip ties to hold it together into a nice stiff strand, and then either a twist tie on the top or something else on the top, whatever you want on the top. You can then just hook it onto the little hook. Leave one strand a little tiny bit longer, and then just hook it on and just let it dangle. So to assemble, you would print all these parts. This one screws into this one from the inside. So from inside of this part, you just reach in, screw, 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 screw. That's done. Then you put this piece, it should just sit right on top of this, should fit right on top. You can glue it on if you want, but I do have dimples for where you'd punch the holes through. You could try self-tapping screws, but you might split the plastic, so be careful. But I put dimples so you can just either hot knife or soldering iron or drill right through that point. Just dip, 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 and then you got 4 screws. Hold that on. This is the only janky part. These 2 pieces have to glue together, and that's going to be a little tricky. That's not going to be super easy. The best way is going to be to sit it on top, 4 little drops of super glue until you get it on there. Add a couple more drops, and once it's pretty solid, then I would actually go in there with some gloop, some 3D gloop. I begged him for one of these mugs. I just had to have it. But I'd go in there with 3D glue to fuse it. But you could just keep adding glue. Just remember, CA is brittle. So you might want to use something a little less brittle, but it needs to be transparent and thin. Because if you see it too much, it's going to really stand out when this lights up. You're going to see an obvious seam right there when this lights up. Ideally, Allied Origins print this as one piece. If you have a printer capable of printing that tall. There is a recreation of the Home Depot 3-foot tall light. It's basically a 3-foot tall C9. I don't need that anymore. That's it. That's all the pieces. 1, 2, 3, 4, 5, 6 pieces. Nice. I am very happy with that. I think that's going to really look nice. Now I got to see if I have any green plastic. I don't think I do. I have yellow and blue. So I can do yellow and blue for this. I don't think I have enough red to print one of these in red. I'll have to see if I have any more red out in the truck. I know PETG in blue and yellow that'll work for this. But I'm only going to make one, so it'll probably be a yellow one. I'll probably print this in blue and then spray paint it green, because I don't think I have any green. Oh, spray paint's pretty expensive lately. It might actually be cheaper for me to buy another roll of filament than it is to buy a can of spray paint. Oh, it's close. It's close. There's Rust-Oleum Accents, $5.98. That's almost $7 with tax. All right, let's look. Can't afford it now. I don't have the money. So the first one's gonna have to be printed in an oddball color. Now the problem with the filament is I need a specific color green. None of these will work. That might work. That would be a good, okay color. This would be better. Not bad. Not bad. Let's see if you can find something cheap. Like $11. There's $12.99. That's a good color too. Not fast shipping though. That's not quite the right green. That's a good green. And of course, if you're going to print a bunch of these, make sure you decide on an available green color, because you're going to want them all to be the same green. It's going to look really funky if they're different color greens. Come on, nothing cheaper? I know there's cheaper, but I need it to be green. It'll also take an entire can of spray paint to paint one of these, while a single roll of filament will probably make 3 bases. No, 2. I should be able to make 2, I think. I'll have to check. It's not a bad green. That's not even green. Why is that even here? Come on. Give me something. Samples. I guess technically you complied. Compliance. Who remembers that? There's 10. With the wrong color. Oh, they have this. Oh, here. 21. Faster. So far, this is looking like the best, but yeah, this is not going to get here. February 8th. Yeah, there's no point. Looks like I might not have a choice. I might have to buy a can of spray. Unless I can find some green. I have to go out to the bus and check. See if I have any green. I doubt it. If I have green, it's probably bright green like this, or it's PLA. Oh, ooh, I love MG chemicals. It's 2.85. It's bright green. That's ABS. Oh, MG chemicals makes good plastic though. That should be kind of cool looking. I mean, you shouldn't use silk, but you could probably get away with silk with a 1 millimeter nozzle. But either which way, I would rather use BGG. I mean, you're not going to have a problem in the winter at all, but you will most definitely have a problem if you store it the wrong way over the summertime. You're going to have a bad time. You go to pull out your lights for next year and be like, shit. Well, don't that just suck? That's pretty cool. Expensive though. Go back to the beginning. It won't be delivered Sunday. It'll be delivered Monday. What I need is a delivered Friday. The only way that's coming Sunday is if they send it by their own shipping, which they're not likely to. So the Amazon system has no idea that they cannot deliver that to me. Oh, that's actually a nice green. A little on the expensive side, but that's a nice green. But now I'm looking for something that could be delivered soon enough. Looks like Sunday is the earliest, which means Monday. Yeah, so I'll just paint one. I'll probably print it in blue. What does Walmart have? The store. Have anything cheaper? Is there a Walmart brand? But Rust-Oleum's good stuff, though. Yeah, just go with the Rust-Oleum. Should I go with this color or this color? This color because it's $1 cheaper. Actually, I don't really want gloss. I have matte. And I probably should use Fusion because I'm painting plastic. Why does it cost so much? Why is it $1 more? Really? Yeah. Probably just gonna flake off if I don't use Fusion. That's the right color. Well, and it's satin too. So get that. Oh, I said in store. Oh, pick up. Really? You sure that's the wrong password? Yep. For Christ's sake, stupid fucking verification codes. It's just Walmart, for God's sake. Well, I guess you could spend a lot of money at Walmart. Left, which means they should have it. Oh, go away. You freaking nag. There we go. Okay. I guess I should check here too. It probably won't be cheaper than. Same price. Oh, it's $1 cheaper. Hunter Green Krylon, $6. But I wouldn't have it until Tuesday. So it's about the same price. Yeah, it's about the same price. Yeah, this is $5.98 on Walmart. This is a different brand. It's Krylon instead of Rust-Oleum. I don't see Fusion. Here's Fusion, $6.98. Same price. It's the exact same price. $7. Is there anything else I need to do to this before I start printing with it? Think of anything else. That should be it. Okay. While you guys are live, I'm going to upload this right now. So if you guys want to print this, you can. Keep in mind, I have not printed this yet, and it's going to use a decent amount of filament, so beware. Screen. Let's do this. Let's do this. This. Take a screenshot. Okay. Take all of this and we put it here. I really hate this. I need to fix this. Much better. I can actually see what the hell I'm looking at now. Why can't I select? I can do that, but not the... Oh, because it's in this stupid mode. But I hate that. So, I'm take all this stuff. I'm just going to put it on printables for now, because I don't know if this is going to print correctly. I don't want to have to update multiple sources. Foot tall, C9. Bulb. Description, there it is. Why? Oh, I keep just missing it. Keyboard's at 60%. Okay. I guess other arts and design. Original model. YouTube link or a... Yeah, it's a fuck up. Bet you I can do this. Paste without formatting. There we go. Oh, it doesn't recognize that it's a link. It should, though. Maybe because I'm in a text box. It didn't work. What the hell? What the fuck? Why isn't it going to the page? That's weird. That's really weird. I've never seen it do that before. Is that some stupid... How? How is it any different than what I just did? Oh, it's missing the end character. It was missing a letter. That's why. That... And 3 times double A. Really? You just ignored the fact that I typed an H? What the hell are you doing? We're back to this shit now? It's something to do with the right-hand shift key. I think the right-hand shift key is getting stuck. Do that again. I will end you. Don't say 5 and show 6. Dorkwad. Mm. 6 pieces. Just publish it. License. Attribution. Just fine. There we go. So if you guys want to try printing it, you can try printing it. But remember, I have not printed this yet, okay? I have not printed it yet. I don't know if this part's fit. They should. I built in enough tolerances they should fit, but no guarantees. All right, I'm going to start printing it tonight. It's going to take me a few days to print it, though. What are you going to weld? What do you mean weld? And I'll upload all the G code and everything to Patreon and whatnot once I confirm it works. Obviously, I don't want to upload it now and then have it not work. So as usual, the file is free on printables. If it works, I'll add it to Thingiverse as well. And I'll also have it available for sale on my site, and it'll be free to my Patreon users. And the pay version will come with all the G code, factory files, everything pre-sliced, ready to go. Go from there. Oh man, yeah, it looks good. That looks very good. Maybe eventually I'll print a bunch of them and put them on a string and run them down the driveway because they'll just look cool. Yeah, that's good. I can't think of anything else I need to do. The hook will glue or screw into the top of this. These two glue together. This screws into this. This screws into this. This bayonets into this. The lights will just hang on the inside. I think that's it. I can't think of anything else I need to do. Well, one thing I could do is make a little bar that you would glue inside the bottom of here, across. Or I can just make it printable. I can make it part of the print. And then, but the only reason I don't want to do that is then it'd be hard for you to stick your hand in there. Maybe just a loose fitting bar that's not actually glued in, that just sits there. And then you would zip tie your lights to it. And this way at least keep the light centered. The light doesn't move around too much. I could print a little thing that you would just lay in there. This way you can push it out of your way when you want to reach in there and change it. Then you just grab it and sit it inside. Actually, I'm going to do that right now. That's easy enough to do. That's really easy to do. That's like stupid easy to do. What was that measurement again? Oh man. Let's just do it right. Control D. Right there. And let's go to 0. Okay, 45 degrees. Because we're going to cross section this. Oh yeah, it's over here. Would you stop it? You're just going to make me angry. I'm going to hurt you. I'm going to break something. I'm going to be upset. I'm going to cry. I'm going to whine. I'm going to break you again for making me break something. The right one. There you go. Michelle. No, I'm on the stream, but I'm almost done. Uh-huh. Yeah. I told her the other person too who called me. Someone called me and asked too. No, it wasn't Heather. It was somebody else. I don't know either. Okay. Yeah. Okay. Obviously. What are you doing? Okay. Yep. What's that? Yeah. All right. Gotta go. Bye. I can fix that delay real quick. Hang on. Okay. Delay should be rectified. Okay. This will look nice. What are you doing? What about that? That's plenty. Go there. Now we need to make this smaller. Let's make it 10 millimeters wide. That's a nice round number. Now I need to take off 0.4. That's going to make it a 0.5. And then I need to take off 2. So 159.5. 159.5. Oh, you can still do that in base mode too. Okay. That should be the right dimensions. Control D. Rotate. Come on. Work with me. And I hate when it moves right before you're done. It's like, really? I don't control D that. What do I call this? Cross? I call it cross. Bulb cross. I don't know what else to call it. Okay. Bulb cross. I can use the same settings I use for this. Perfect. Uh-huh. Really? You clicked it, Chris. Cross. Should not be any zones. Okay, 2. No top and bottom. There. That's fine. Only 38 grams. It's perfectly fine. Okay. That's port. Bulb cross. Yes. Save. File. Save factory file. Okay. Now let's add this to the files on here. Edit model. And cross. Okay. There we go. So that piece there, like the cat in the other video, but instead of removing material, it would be added. Yeah, you can do the same thing. You can add anything you want to it. Oh, because you want to actually add color, then you'd have to have multiple perimeters if you want to do an actual lithophane kind of thing. So if you wanted to emboss it so that that part was darker, yes, you could do that. You wouldn't be able to do vase mode. You'd have to turn off vase mode to do that, but you could do it. Okay. There you go. It's done. All I gotta do is print it now. I am happy with that. Can I think of anything else I need to do? So this will sit right inside the bottom of the bulb. And it just sits there. It doesn't glue or anything. You can do it in vase mode. It'll just be monotone. You won't have the shading effect, but just the changing angle of the plastic will alter the light. You will be able to see the shape. But if you want to have a true photographic effect, if you want to create like a lithophane effect, then yes, you'd have to turn off vase mode and use multiple layers. You're going to have to be real careful with that because, well, no. If you just use the brighter set of lights, the $5.50 set of lights, that'll produce more than enough light to light up a lithophane. But the little fairy lights might not. So, although if you did it with a 0.4 millimeter nozzle, you could probably get away with that. But boy, would that be a long print. But yeah, that would work. You'd have to figure out how to do the shading. That would be tricky, but it could work. So yeah, this will just sit inside the light here. You could probably flex it enough to shove it in from the bottom, but otherwise you just drop it in before you glue it in there. And you don't glue it in place. It just sits there. And then if you need to get inside the light, you just push it out of your way, reach in there, do what you got to do, and then just settle it back into its little cradle. And then what you do is when you have the lights hanging down, you hang them from that cross. You zip tie them to the cross. And that way, I would even zip tie like the screw hole if it has one. Let's see if it has one. Oh, man, oh man. Yeah. See the little hook on the top there? I put a zip tie through that hook or a string through that hook, and I would hang that from the cross. This way it's not pulling on the wires. And then also twist tie or zip tie your light band to the cross. So what you're going to do is you're going to have a... I don't have any lights to show you. You're going to have I guess this is the best thing I can use right now. you're going to have a string of lights. So a string of lights like this. And the problem is your lights are going to be 7 feet long. It's only 3 feet long. So for the 7 feet long one, that's about 3 windings, maybe 4. So let's say you determine, I'm going to do the small scale so you understand. Let's determine you need this much light. Well, what you would do is you would start doing this. And you would just start doing this with your lights. Whichever end ends up with the battery box, you just have that end facing down. And then what I would do is I would take and have one of these strands reach up a little bit further. Or put a zip tie on here and make sure the zip tie is open on the top. Okay? Don't do it tight. And then zip tie here, zip tie here, zip tie here, zip tie here to form basically a light stick. Okay, you can even stick a dowel rod in there if you want to keep it nice and straight, but these copper wires will have no problem staying straight. And then what you do is you just reach up inside the light and you take your little hook, your little zip tie hook, and the printed hook you made that you already screwed into the top, you just go whoop, and you hook it. This part here dangling down, you made it long enough because you measured this in advance. Now it's going to be sitting there resting against that cross that you drop inside there. And what you do is you pull it slightly taut, don't pull it tight, just pull it so it's straight, and then you zip tie it to the cross. And now your light will be a filament running up the center of the light like that. And then you put a zip tie loop on your battery box that also hooks around the cross, so that your battery box that weight isn't pulling down on your light string. Especially if you add the 2 extra battery boxes to increase the capacity. Especially if you do that. You're going to want to do that. But otherwise, yeah, that's it. You're going to have a light string that's going to be wound up like this. Mine's going to be wound up 60 times. Because it's 33 feet long. So I'm going to have to keep going to wind that up to make it sit in the center of that light. And it's going to look like this. It's going to be a strand of lights just hanging right there in the middle. Now, what I'll also do is I will make a different interface plate. That will be this piece here. Now, what I'll do is I'll make a plate that goes inside here. That you'll screw in. That will have a socket, a hole on it that you can then take those sockets that I linked to before and just screw those sockets into it so you can run mains power if you want, for example. I got to do that a little differently. What I'll probably do is make a little extension cylinder that'll attach this, just a 5mm extension. So you'll screw the light socket into this, and then you'll screw that into the phase mode. And, that one might even go in reverse. It might stick inside of here, and you'll just screw into it from the outside. And we'll see how that works. Oh yeah. Here. So when I have time, if this works, I'm going to do this version first. I want to get it done. But if it works, I'll make a plate that goes in here. And that plate will have just a hole in the middle. And that hole you'll put your light socket in, wire up your 110 volt power or your 12 volt power, and screw a light bulb in so you can use a light bulb. But this one here is made for just using a string of fairy lights like this. You can get them for $5. They're $5.93 with tax. And if you want to make a whole bunch of them, you use these. They won't be as bright, but they'll be a lot more efficient. 14 feet, so you'll have to wind that a few times. It's 40 LEDs. That's all you need to know. You'll just dangle this from the inside of the fixture. Just whatever lights you buy, just make sure that they're timer based. Otherwise, you got to turn them on and off, or they're just going to drain your batteries. With the timer base, so you just switch the light to timer in the middle, and it will run for 6 hours and then turn off for 18. That's what you want. Make sure it's AA. Don't get AAA ones. Do not get the button cell ones. It's very easy to make Sure, it's a big box like this that takes AA batteries, whatever one you decide to get. What you do not want is this. This will work. This will work great. In fact, it'll be amazing. It'll be super lightweight, and it'll last for about 1 day. And then you'll be replacing the 2032 cells in here or whatever's inside there. I don't even know what's in there. Boy, it's even got all the same modes, timer modes, and it does timer in all the different modes. Nice. I don't know how long this runs, but it's not going to be all winter. I can guarantee you that. Not with two 2032 cells inside. I mean, you can get 2032s pretty cheap, but that's going to cost you a lot of money. You could probably get 20 if you really want to go super lightweight. You probably can do that. Like if it's just for a party or an event. That is a very cheap way to do it. Here's a 10-pack for $6, so that's enough to do 5 lights. Here's a 20-pack for $8.49. That's cheaper. And here's where you get into a good deal. 25 cents a battery, so that's 50 cents per light. You're looking at 40 of them. That's enough to do 20 lights or 10 lights twice when the batteries run down. But that's just a waste. Now, something else you can do if you're going to make this is something else you can do. If you just like want 1 or 2 of these for inside your house, just get USB fairy lights. There you go. $6.99. This even gives you all the more. Here's 2 of them for $7. USB fairy lights, 33 feet, 100 LEDs. That's lots of LEDs. You're going to be winding that up a lot, but that's okay. There's nothing wrong with that. You wind them up inside there, and then you just plug a USB cable into it. Done. Sitting on your kitchen table, or sitting next to your tree, or in your living room, or your family room, or something like that. Perfect. You just run the damn things off of USB. And if you want to get fancy, well, you can hook the USB like powered thing up to a switch. But they also have RGB ones. Like in your house, the RGB ones would be pretty cool. Like here is an RGB one. Again, 33 feet. You just keep wrapping it around. It'll make it nice and bright. And what you do is you print these with like a either a really translucent milky white or even a transparent PETG. Milky white or PETG is always a little bit transparent, so white would be good. You print this in white, and then you just use the remote and change it to whatever damn color you want. And you're gonna go, I'll make that one red and that one green, and you can dim them, flash them, you can do all kinds of things. Oh, this one does 24 colors. It's only $19. And if it's not bright enough for you, if you want to make them ridiculously bright, just get the 66 foot. Now you have 200 bulbs. But again, your stick is going to be this long. It's going to be as long as the inside of the bulb. As long as the inside of this. So you're going to make a string approximately 580 millimeters long. Okay, because you have a little bit of length from this. So about 570 millimeters. Okay? So you just take a 570 millimeter ruler and you just start winding light around it. And you just keep making strands. And then you just zip tie them together or tape them together. So you have basically a light stick that's 570 millimeters tall. You put a loop on one end and a loop on the other end. And you hook it to the hook on the inside. And you attach it to the cross at the bottom. And, just tape it or zip tie it or twist tie your bread twist tie or something like that. And then, a separate hook for the light box, a little box. Although with the USB one, you don't need that. And that's it. This would look. I can't afford this right now, but I'm gonna save this just because I think that's a great idea. I really want the 24 color one. I'll see if there's a better deal on this. Now, within your house, that's where it might be better to use an RGB bulb. So here, $6.99. Even better is one of these. No, maybe not better. This might actually be better. Or something like this. One of these kind of bulbs where all the light shines up. These would work fine. 9 watts is a bit much. I'd want to hear 5 watt. That's what I would go for. I'd go for the 5 watt. Much better. You don't need that much power. But 2700K white or 16 color choices. So for inside your house, this is great. You can sit there with the remote and just whatever color you want. There's 2 of them for... Wait a minute. 2 of them cost more than 1. What the hell? Oh, these are Bluetooth. So these can connect to your phone. Well, that's even better. So $15, you can get 2 of them and connect to your phone. That's cool. You know, there's so much you could do with this kind of thing. I'm also hoping that I can do more with this. I keep trying to rotate it as if I'm in Tinker. I'm sitting here trying to drag it, trying to rotate it like it's in Tinkercad. Oh, I'm a goober. I keep trying to do this, you know, to make it do that. Oh, man. But what I also want to do, if this works, it'll be a little harder since you can't use vase mode for a lot of these different shapes. Make different bulb toppers. So maybe have a permanent set of these outside. You know, maybe I will, instead of doing it in vase mode, print it with infill. You know, actually print it strong, like 3 1mm perimeters, 10% infill or something like that. You know, real light infill inside. Why waste so much plastic? Put them out there permanently. Permanently install them out in my yard. And then when it's not Christmas, put a ball on it. So it's just an area light. You know, it's just a regular old light. Then like for example, Easter, I can print eggs and Easter bunnies and put them on top. And for Valentine's, print a red heart. For St. Patrick's Day, print a 4-leaf clover. You know, for different holidays, I can print different toppers to put on top of this light. In that case, what I would probably do is make a version of this. Well, in that case, I would probably be using regular bulbs. I'd probably be using the E27 bulbs, because then I wouldn't have to fiddle with changing the light inside the fixture. In that case, that's exactly what I would do. I would redesign this to use a regular E27 bulb, and then I could even adjust the color if necessary, although warm white would be plenty. And then when each holiday comes by, or a birthday party or an event, whatever, I can just design a new one of these things to go over top of it. You would just bayonet it into place, install it into place. With 4 bayonet points, you have 4 different angles that you can angle it, so you don't have to worry about it not being what you want. And yeah, that would work. Now, in that case, I would probably print this, and this is one piece. And and I would probably have screw holes in the bottom so I can actually mount it into the ground or onto a wooden post or something like that. A lot of different things you could do if you're going to permanently install something like this. Then when it's not a special holiday, you can just put a plain, you know, white ball on top. You can even make like a pagoda top so you can reflect light down, because I don't like general light here because it ruins the dark sky experience. So it'd be pretty easy to design a little, you know, I'll show you what I mean. This kind of thing. You know, to design something like that. You know, something shorter that's not going to just blow a bunch of light up. It's going to blow most of the light down. There's some nicer ones too. That style right there would be easy to do. Just get some acrylic and fat something. You could do stuff like this. Um, but yeah, stuff like that. We could make different designs to put on top of it. So you can, and in that situation, I'm trying to drag it again. In that situation, I would make this a little more substantial. I would put more meat into it since it's going to be out year round. Although I could probably still do this in vase mode. I could do my complex vase mode with an inner cylinder. That would actually be really easy to do. That would be really, really easy to do. I'll do that. I'll do it in vase mode just because I'm a sucker for vase mode. I really like vase mode. But yeah, I could do this in vase mode. I would do it like my rocket body tubes. With a 1mm nozzle. Come on, give me a break. That thing's going to last forever. Oh, yeah. That would freaking work. That would absolutely freaking work. Okay. You can even put flame bulbs in there. Oh man, you can do all kinds of stuff. If you want to get crazy fancy, you can get the lights that have the different modes, and instead of hanging it from the center, you can actually tack glue it to the top, and then go around, glue, 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 and you can create a spiral inside the bulb, like cover the inside surface of the bulb with the string of lights, and then you can use like the wave motion and continuous and blinking and flashing modes and all the different modes that you can get for the lights. That would look kind of cool, especially if you printed a cylinder and you line the cylinder with it for like non-Christmas events and stuff like that. You can do all kinds of neat things with that. Huh. And the nice thing is these can be basically permanently light installed. You can get yourself some decent RGB individual emitter controls that aren't permanent lights, so they don't cost $100 a string. And you could basically make them permanent lights, because what the difference between permanent lights and non-permanent lights is the mounting method and also the quality of the components. If the cheap fairy lights, they just don't hold up over time. The UV from the sun and the weather and the snow and the rain just beats the hell out of them. But if all your lights are inside of an enclosure, well, they're gonna last years because they're protected. They're not getting beat directly by the sun or the elements. So, yeah, that could work. Very cool. All right, that's it, guys. I'm gonna skedaddle. Um, I got lucky. I got $45 off of Ibotta this month, so I was really worried about how I was gonna go see Michelle next week because I don't have any gas left. I got an eighth of a tank. I had an eighth of a tank, and I used that to go see her this Monday, so I have no gas left. I probably would make it to her, but oh man, my eyes are bad today. I would probably make it to her, but not make it back. There's not enough gas in the car. But now that I got that money from Ibotta, I can fill up the gas tank. Because she's lonely there. She's really lonely. It does make it bigger. That's it. I will see you guys later. See you next week. I'm going to try to have one of these printed out by next week. The printer is working smoothly and reliably. I just got to go dig up some filament for it. I'm going to try to find some green filament so I can cancel that spray paint order if I can. I'd rather not spend the $7 on that spray paint order. I guess it technically doesn't have to be green. I mean, I could make it I could make it blue. But it would look better if it was green. Black would work too. Black or brown. That's it. If you want to help me out, PayPal, Zelle down below. Amazon link, Temu link, AliExpress link. And this is okay. Let's talk about AliExpress. That's another reason why you always check this stuff. Okay? I mean, look at this. This is $17.99 for 12 of these that take 3 AA batteries. So this is the good ones. All right. Perfect for a project like this if you want it to be wireless. If you don't want to wire it up permanently, if you want to run it on batteries, it'll be here in like 4 days. It would have been 2 days if I ordered it earlier. Okay, but now that the holidays are here, it takes a couple extra days. So that's $1.50 a light. Now the best price I could find on AliExpress was $2.34 a light. $241 now. Here's $205. This one's USB, so for in the house, this would be perfect, and that is actually cheaper than Amazon. But this is the one that we're looking at on Amazon. This is the same thing right here. 2 meters. It's actually a little smaller. The one on Amazon's 14 feet. That's 3 meters. No, it's more than 3 meters. My head hurts. I can't think straight. That should be easy math. 14 feet to meters.
14 feet is 4.26.
4 meters. Okay? This is half the length and half the bulbs. That one was 40 bulbs. This is 20 bulbs. Although, this might be better for the lights. Only because, assuming the bulbs are being driven at the same current, and not twice as bright because there's half as many, this will last longer. But $241 is the best deal I could find. Now you're going to buy more than one. The minimum is only $10. All right, so 10 of these will cost you $24. These have twice the bulbs and they're twice the length, and they're $6 cheaper, and you get 2 more. AliExpress is not always the cheapest. You got to look around. Now, if I were to do just regular warm white E27 bulbs, like, sockets, I would use these. This is the cat's meow for that. 6 of them for $6.37, or 15 of them for $16.48. So you're paying just over $1 a piece. What? Oh, 10 of them for 20. That's your sweet spot right there. $10.27 for 10 is cheaper than both of these per bulb. And you're probably not going to do more than 10 of these, but 1 watt. They're dimmable, which is nice. You can put these on a dimmer circuit, and if they're too bright, you can dim them down, save some power. But let's get real. All 10 are only going to consume 10 watts. You're not even going to feel that on your electric bill. Right? They have them in 220 and 110, cool or warm white. Cool white will be a little bit brighter. Warm white will look a little bit better, depending on what you're looking for. If you like that nice, cozy warmth of the tungsten filament and the old-style Christmas bulbs, you want the warm white. If you want the techno, Blade Runner, modern, cyberpunk, bright white, or the happy, giddy, bright Christmas lights, then you want the cool white. It depends on whether you want the yellow or the blue. But these are perfect. They're little tiny T28 little tubular bulbs. Absolutely exactly what you would want inside something like this. 1 watt, exactly what you want. You're going to have a tough time finding a deal like that on Amazon. But this, not a good deal. This is a much better deal. Much better deal. You get 14 feet instead of 7 feet. You get 40 LEDs instead of 20. And you get 12 of them instead of 10. And you get it in a couple of days instead of 2 weeks. Air rocket foot bomb launcher. I like AliExpress. I find a lot of good stuff on AliExpress. But there are some things that are not as good a deal. Now, if you want those little tiny lights, oh, you can't touch AliExpress. Oh, that's actually a pretty good deal right there. Oh, there's a good deal. That's not bad. Now, see, that's a pretty good deal. 2 meters for 20 LEDs, $1.71. If you only need a couple. But as soon as you need more than a couple, it's cheaper to buy the, like this one, What's the difference here? 5 meter, 50 LEDs, 10 meter, 100 LEDs. Now, see, this is not a bad deal. 10 meters, 100 LEDs, 238. That's a good deal. But for what we need for what we're doing, that's a better deal. Now, if you want those little tiny ones that run on button cells, like these run on the LR44s, okay, and then you have the ones that fit inside the wine bottles. You know, okay, that's much better deal to buy those on AliExpress or Temu, like this here. Here's the wine bottle ones. I'm not on the right screen anymore? God damn it. AliExpress, okay? So these go in wine bottles. You're not touching that with a 10-foot stick. It's 82 cents each. And you could buy 12 packs of these. Dirt cheap. Dirt cheap. These are great for rockets because you get 10 of them for $7, and they run on the little LR44 batteries. You know, they're not cheap to run, but when you're flying a rocket, you don't care about cheap to run. What you need is compact and lightweight. But this, it's only 7 feet and 20 LEDs. This is 14 feet and 40 LEDs, and it's significantly cheaper. It's 92 cents cheaper each, and you'll have it in 2 or 3 days instead of 2 weeks. So, but only if you're making 12 of them, 10 or 12 of them. If you're not in a rush and you're only making one, well, then you buy it for $2.38 on $2.41 on AliExpress, because the cheapest you're going to get one on Amazon is like $5. But yeah, you just gotta look around, okay? Don't just think, oh, that's a great deal. No, look around. Yeah, sure. If you're buying, you know, a nice little bracelet and it's $1.31, don't look around. Just get it. Unless you're buying $40 to $50 worth of stuff where 40 cents on each item will save you a lot of money, just buy it, okay? You know, this was $1.60. You know, I could spend an hour and maybe find it for $1.30. Ooh, wow! I just wasted an hour of my life. But when you're buying something, you know, where you're something like this, it's worth looking around. It'll only take you a couple minutes, and it'll save you a lot of money. This is 18 for 12. And that one is 24 for 10, and you get half the lights. So shop around. All right, yeah, I'm going to do that. I'm going to make a more permanent version of this, double wall vase mode. And I would really love to work on building a printer tall enough to print this in one piece, because this would look so much nicer in one piece. I know I'm going to absolutely hate that seam. It's not going to be that big a deal. No one's going to notice it but me, but it's going to drive me crazy. I know that seam's going to drive me nuts. And if you need an electric screwdriver, just buy one off AliExpress or something like that. I mean, you even, I think even on Amazon you can get one for $10 or $11. They're just not expensive. There's no point in spending a lot of money buying a little screwdriver like that. All right, that's it. I will see you guys later. Thank you for joining in. And I don't know if I'm going to do a stream next week or not. I probably won't. There's probably not going to be too many people online on Christmas Day watching, you know, lame me do a 3D printing stream. Maybe I'll do it Thursday. I don't know. Maybe I just won't do it next week. We'll see. Maybe I'll try to get this done by next week and post a results video. Maybe I'll do that. This way people can watch it whenever they want. But you guys have a good night. I'll see you later.